Dear God, thank you for the opportunity to meet together. Please help us to come together to make this institution reflect your kingdom. Breathe life into our ideas and decisions. Help us build a team that has love and respect at its heart. Give us the strength to continue working for your kingdom in this time of pandemic. Lord, come give us the inspiration to be the best we can be. May we be a shining example of your goodness and truth within, wherever we are. Inspire our thoughts, discussions, and ideas, and continue to remind us that all that we do here today, all that we accomplish, is for the pursuit of truth for the greater glory of you. We ask these things in your name. Amen.
Mga kababayan, ang pambansang awit ng Pilipinas. Kayang
Hello global participants, maayong gabi gikan dire sa dakbayan ng General Santos. Isang magandang gabi sa ating mga kalahok na andito sa bansang Pilipinas, and good afternoon to our Middle East participants. Happy Trio-CPD-nario everyone. I am Bai, your host for this webinar. So before we will proceed to our program, let us do a quick video and audio check to ensure everything is okay from your end. So I am requesting our dearest participants to please type hashtag Trio-CPD-nario in our chat box or in the comment section of our YouTube live to show your support to our beloved Team Ross and to ensure that you can hear and see me well. All right. So thank you so much. That's my cue. Thank you so much for our engaging participants and welcome to the opening salvo of our Trio-CPD-nario 2.0 webinar series. Welcome to our webinar entitled Scientific Professional Audio System Designing Principles. This is indeed a momentous event to your beloved trio, the Team Ross, Rizal, Oman, and Soxurgen, as these three chapters join forces to provide continuous learning seminars to electronics practitioners. Team Ross is hosting 4 technical webinars for all of you this July, and we are immensely grateful that IECEP participated or represented by Team Ross, stay true to its commitment to bring you the best webinar showcasing our profession and the latest in electronics technologies to advance humanity. So to our participants, I am requesting you to so that you will engage to our speakers. Just let us try to use our reaction button. So if you can see the reaction button in your screen, can you please hit the thumbs up button? All right. So thank you so much. So I hope that we will have this kind of participation all throughout our Trio-CPD-nario. So we hope that this Trio-CPD-nario will bring triple fun for 4 days of learning. So sit back, relax, and enjoy learning with us. So tonight, to kick off our program, let us hear a message from a purposeful and passionate leader. He is indeed a strong leader because he embodies his message. As Brendan Burchard once said, leaders have to stand for, demonstrate, and show and portray what they really believed in. So ladies and gentlemen, help me welcome. So now, can you click your clap reaction button in your screen and help me welcome our IECEP Oman our IECEP Oman Governor, Engineer Jimmy Santos. Hello, Gov Jimmy.
Hello, Mambay. Good evening. Is my audio clear?
Yes, sir, clear.
Okay. Thank you very much for that very generous introduction, Mambay. So I'm not going to make this message long, so I'm not going to take more of the time for the speaker to give us the lecture. So on behalf of the IECEP National Board, headed by Dr. Michelle Lawas, and my fellow governors, ASEAN Engineer Dennis Molina and Engineer Tanya. So in behalf of the officers and members of the 3 chapters, I welcome everyone and I wish you all safe wherever you are, and mabuhay tayong lahat, mga ka-IECEP at mga ka-electronicos. Enjoy the rest of the day and the rest of the night while listening to the lecture of Engineer Wayne Gotor for the topic. So magandang gabi at magandang hapon po ulit sa lahat.
Okay, thank you so much, Gov Jimmy, for that warm welcome. So I want to inform everybody, to our participants and guests, that this session is being recorded, and by joining this webinar, you are consenting to be recorded. And we are also streaming live in our IECEP National official YouTube page. So just visit youtube.com/ICEP National Official, or you can scan the QR code shown in your screen so that you can visit our live stream. And to our participants, we are requesting you to hit the subscribe button of our YouTube channel and click like and share our YouTube live to show your support to our ICEP National and of course to the beloved Trio-D Team Ross. So shout out to all our YouTube participants and enjoy learning with us. All right. So before we proceed to our technical session, let us first orient ourselves with the house rules to ensure that we will have a smooth, fruitful, and engaging webinar. So may I call on our beautiful and charming ICEP SOC Surgeon Secretary, Engineer Tony Abiera.
Hello everyone, good evening. Naririnig po ako?
Yes, Tony, we can hear you loud and clear.
Yes. Thank you, Ma'am Bai. So again, good evening everyone. So here are the following house rules that should be observed in this webinar. Okay, so first, turn off your microphone and your webcam. Type your registered name as your participant name. The name you will be using upon sign-in shall be cross-checked with our list of registrants, and the same would be reflected on your e-certificate. Be respectful. Treat everyone how you would like to be treated. Be an active participant. You may direct your topic-related questions in Zoom's chat box or in the YouTube comment section. Please do not directly message your questions to the speaker. We will try to cover all of it during the Q&A session. No spamming in the chat box. You are enjoined to attend the whole duration of the webinar. We have a strict attendance system in place, and checking shall be done from time to time. Your attendance will be invalidated if you do not complete 90% of the session. An evaluation test shall be provided to gauge the learning gained in this webinar. The attendance quiz evaluation form link shall be posted in the chat box after the Q&A session. You are urged to accomplish this form before the webinar ends. The attendance shall be submitted to PRC, or that is the IECEP Council, immediately after the end of this webinar. Keep an open mind and enjoy the webinar. Thank you, Ma'am Bai. Back to you.
Yes, thank you so much, Engineer Tony Abiera, for that one. So now that we are oriented with the house rules, so let me just first discuss to you one of the frequently asked questions, which is how to qualify for our e-certificates. So to qualify for our e-certificates, first is that you have registered in our event. Second, make sure that you have completed 90% of the session, because our main purpose here is to ensure that you will gain knowledge and skills from our session. Third is you have passed our evaluation test. And lastly, you have accomplished the post-webinar evaluation survey. So we will be posting the links for our attendance quiz and evaluation form in our chat box and in our YouTube comment section as well. So we enjoined everyone to please accomplish this form before the webinar ends. And please note that your certificates will be available in our My ICEP website. So I know that everyone is excited to our technical session, but first let us showcase our ICEP webinar, our opening salvo of the Trio-CPD-nario by posting to your social media accounts, by sharing also our YouTube live using our official hashtags, which are hashtag Trio-CPD-nario, hashtag #OneICEP, hashtag Team Ross, and hashtag Mabuhay ICEP. So moving on, let us now proceed to our technical session. So the art of sound reproduction has been a fascination and interest worldwide. Speech and music are the most basic means of adult human communication. So the desire to be heard by the masses is evident in today's society. So for example, in public speeches by the president, music festivals or concerts, and church services. Many Social and professional entities rely on sound production to convey their message. And to be able to reproduce sound clearly and to project it for a distance involves many factors. That is why this is our first technical session of our Trio-CPD-nario webinar series, which will provide you insights on the scientific professional audio system designing principle. So, ladies and gentlemen, to introduce our resource speaker for today, help me welcome our IECEP Oman trustee, Engineer Rizal. Hello, sir. Good evening.
Good evening po sa inyo lahat. Loud and clear po?
Yes po, sir. We can hear you loud and clear.
So, magandang hapon or gabi sa ating lahat. And hello to our fellow participants. It is a privilege to introduce... Hello? It is a privilege to introduce our resource speaker for today, Engineer Merwin Wayne A. Gutor. So, he's a licensed electronics engineer and has finished his degree in electronics and communications engineering at Central Visayas Polytechnic College. He has worked thereafter at the Yupanco Electronics Corporation and Audio Video Solutions Corporation as sales manager, project manager, and head of system design and applications division. He's currently the vice president for System Design and Application Division at Metatech Solutions and Systems Corporation, which deals with professional audio, video, lighting, multimedia, and systems. He has attended several trainings, both local and overseas, regarding our topic for today. Apparently, he has built up his career and made a substantial network of clientele consultant practitioners in this profession. With more than 15 years of experience in sales and marketing of product management and supervision of sales, technical personnel, and project installers, particularly in professional audio system design. It is with great pleasure and gratitude to hear from our resource speaker for today. Without further ado, let us all welcome, this will really be loud and clear, Engineer Merwin A. Wayne Gutor.
Thank you very much, Engineer Rizal. Can you hear me now?
Yes, sir. We can hear you.
Okay, I'll just share my screen.
What we can see now, sir, is in the presenter view.
Yes, I understood. Okay. I'll just make some few adjustments of the screen. Engineer Bai, nakikita niyo na yung screen ko?
Yes po, sir. We can see it now.
Okay. Good evening po sa lahat dito sa Pilipinas. Good afternoon, good evening sa mga kasama natin abroad, sa Visayas and Mindanao. Maayong gabi sa inyong tanan. Basically, when I was invited by Engineer Molina to share, actually, mas gusto kong tawaging workshop or sharing itong session instead of webinar. Kasi sa practice talaga namin, mas maganda yung workshop or may interaction talaga. But unfortunately, this time, hindi tayo allowed or hindi tayo capable. So, mag-stick muna tayo dito sa webinar. Tonight, I'll be sharing with you several ideas or technical knowledge in terms of the perspective of a designer. That's number one. And also in a perspective of a user. Uh, and then another thing is in the perspective of parang sa owner side ng mga projects that will be designing. Okay? So the topic this evening is scientific professional audio designing principles. So this is a continuation actually of a webinar that I've conducted last December 20 of last year. So that was just a intro about designing principles. And then I'm glad that I'm invited again to share with you the scientific approach. This is the next topic about designing principles of professional audio. Okay. Let me begin with this slide now. Okay. So let me share with you these previous 4 slides that I've shared last webinar. It's about developing a logical system architecture. So we have 2 fundamental steps. First, these are just the basic fundamentals. We need to analyze the application for the system, covering technical and budgetary concerns. Alam naman natin na pag nag-design tayo ng system, meron talagang technical and budgetary considerations. Okay? Next one is we need to determine the functions that will be required, and then saka tayo makapag-develop ng list of equipment. These are the 2 basic fundamental steps. Okay? And then later on, for the standard design approach, we need to study first loudspeakers. So there are several components of the sound system, but mas nauna itong loudspeakers. Later on, we will be discussing it thoroughly. So about the loudspeakers, we need to study the type, kind, and specifications, etc. Sorry. Next is the power amplifier driving the speakers. Next is sound sources, microphones for speech, instrument, recorded and streamed music. And then next is the interconnection, because nowadays the technology is going into a network system and even wireless system. So to add to this, there are also 6 basic steps of a standard design approach. Next, of course, you need to establish the required system. Next is to analyze the environment, the characteristics of the environment, which we'll be discussing in detail later on. Number 3, again, choose the loudspeakers on the basis of the nature of dimension of the space. So this is more on the space and the type of material, and of course, considering the noise level of the environment. Next, we need to define the sound sources. And then we need to choose the amplifiers. And then, of course, we need to evaluate the connection for the speakers and other devices within the sound system. So these are just the foundation, the standard approach, and basic steps of coming up with the system design. But our topic outline for today is about these 3 items. The first one is the basics of room acoustics. Actually, I would just like to make a parang disclaimer na we need to discuss this one about room acoustics, but I'm not an acoustic engineer or architectural acoustics practitioner, but we have also experiences and knowledge regarding basic room acoustics. gained from our mentors in the industry, from the seminars, and from the lectures that we've also attended. Okay. So the reason why we need to discuss this is that because we need to understand the architecture of the space and room and the acoustical defects in sound system. Okay. Uh, Next topic is about the 7 sound system design objectives. Ito yung pinaka-detailed na discussion natin this evening. And the third one is the 3D room modeling and sound simulation software. So I will be conducting a actual demo of room and speaker modeling later on of 2 models of simulation software. This is, I think, this is very interesting for all of us. So please watch for it later on. So these are just the 3 contents of the discussion this evening. Okay, to begin with, we will just review the basic principle about sound reinforcement system. So it states here that a sound reinforcement system should be able to accurately amplify, reproduce, and or record a signal from its input through any processing to its output without any coloration or distortion and adhering to a particular standard of performance. So meaning, the main objective of the system is to accurately amplify. So may mga factors kasi kung bakit hindi nagkakaroon ng accurate amplification yung system that we'll be discussing later on. And another word here is words here or phrase is without any coloration or distortion. So this is now the challenge in designing a system, not only in designing phase, but also in the implementation phase up to the calibration and testing and commissioning phase. So this is the real challenge here. And the last phrase here is adhering to a particular standard of performance. So meron tayong sinusundan na performance in terms of the coverage, the level, and the frequency response of the system, which we'll be also discussing. So basically, this is the overall purpose or concept of sound reinforcement system. So just a quick review. So this is the components of the system. We have the electroacoustic part. This is the input section with human voice, instrument, and music. And this part here is the signal processing with preamplifiers and volume controls. Here is the signal amplification, the power amplifier section. And at the end part of the system, at the output part is another electroacoustic component, which are loudspeakers, headphones, in-ear monitors. But there's another part of the system that we need to consider, which is the environment. Ito yung madalas nakakalimutan, as I have mentioned in the previous webinar. Ito yung madalas nakakalimutan. This is a part of the system. Yung sound system hindi lang electronic equipment or hardware. Kasama talaga yung room and environment. And in our experience as designer, as user, as supplier, integrator of the system, hanggang yung end user is kasama sa sound system. So that's the real picture of the sound system. So not only on the devices, not only on the environment, but also the end user of the system. Okay, so this is just I'm just laying down the basics, the foundation of the sound system. First step is the basics of room acoustics. Okay, of course, we are aware of this, that this is part of the room acoustics. Uh, from a source, part of the sound will go directly to the listener and part will be absorbed and reflected by walls. Of course, we already know this. And then part of the basic of acoustics, the RT60 or the reverberation time. Of course, we know that RT60 is the amount of reverberation in space equal to the time required for a level of a steady sound to decay by 60 dB after the sound has stopped. Okay? Ito yung madalas na ginagamit or ito yung madalas na nababanggit ng mga acoustic engineers or acoustic designers sa field. Next, last 1898, this is a formula developed by Wallace Sabine, which is published in 1922. Ito yung pag-calculate ng reverberation time in a room. So, please take a look at these items that I have highlighted here. So, ito yung mga common na mga materials na ginagamit natin sa mga construction ng buildings and rooms. And please take note also of the absorption coefficients with regards to the frequency. Okay. Next, this is part of the basic of acoustics. For a general purpose auditorium for both music and speech, so ito yung target talaga ng mga acoustic engineers in designing a room or treating a room. So from 1.5 to 2.5 seconds. Okay. So at this part here, with smaller reverberations, this part here is applicable for speech. And this part here is mostly applicable for music. So 3.5 seconds as a characteristics which is ideal for music applications. But the target here, the most target here is the 1.5 to 2.5 seconds. Okay? This is the reverb time chart for the different rooms and venues. Kung makita nyo dito, these are the common venues that we have encountered in our environment. Pero napapansin nyo dyan, wala yung restaurants. Okay? Saan natin ika-categorize yung restaurant? Okay?
Mamaya at ang mga MGUs para sila. Number 3, Monte. Senator Bongbong is the big honest with you.
Ikaw na yan, Ben! Sumasagot ka na ka
We will discuss the 7 sound system design objectives. Ito na yon. Ito na yung kumbaga, ito na yung the most challenging part in designing a sound system. So, there are several objectives, but I've just listed down 7 important. The first one is respect the architecture of the space. Minsan may mga biruan nga kami sa site or sa mga projects na aside from respecting the architecture of the space, we also need to respect the architect of the space. So ito yung biruan namin kasi of course, we also need to consider yung design ng arkitekto. Minsan sa actual na application talaga or actual na experience namin, we need to deal or negotiate or discuss thoroughly with the architects of the space. Kasi minsan meron tayong ilalagay na speakers dito dahil it is required for the venue. Unfortunately, ayaw ng arkitekto or ayaw ng interior designer. So, kaya nga sinasabi namin, we also need to respect the architect of the room or the space. Okay? So, to effectively design a sound system and create a high sound quality for music venues or speech listening room, we need to learn the science behind sound behaviors. Okay? So, as part of respecting the architecture, kailangan nating malaman yung behavior ng sound inside a room. Okay? Some sound behaviors can improve or degrade sound quality inside the room. However, sometimes it depends on how you control those behaviors so that the sound waves can act the way you want. So minsan, alam natin yung character ng isang room. So pag alam natin and we are aware of it, we understand it, doon pa lang makikita natin kung paano natin i-control the list. Kasi minsan, may mga rooms talaga na may encounter tayo na hindi talaga siya treated. So that's the challenge there. Pero kung may budget yung talaga, owner ng room or ng building to have the room or walls or any surfaces treated, mas maganda. But based on our long experience, most of the venues talaga na kailangan natin mag-design ng system is very reflective, very reverberant. Okay? So, first, we need to check the behavior of a sound in a room. Of course, this is basic. We know that sound waves has property of reflection, diffusion, absorption, of course, diffraction, and this is the one of the sometimes neglected characteristics of a wave, itong resonance. Okay? We also need to here just to discuss quickly. Resonance is a phenomenon in which sound waves have frequency that matches one of the natural frequencies in the room. So meaning, at this figure here, the sound pressure at point A and C is of the highest magnitude, while in point B, the pressure is 0. Okay? And then if you are at point A or C, you will hear the sound louder compared to point B. So, imagine lang natin how bad it would be if these frequencies come together. Okay? So, in this case, we also need to understand resonance. Not only these four behaviors of sound in a room. Okay? Ito na yung malalalim na pinag-aaralan ng mga acoustic engineers. Aside from these four behaviors of sound in a room. So, that's why we came up with this statement that at the most basic level, it is safe to say that any room having complex yet symmetrical interior geometry will complement sound better than a room with simple and or asymmetrical geometry. Kahit complex ang room, basta yung mga walls or floors or ceiling symmetrical lang, mas madaling i-deal in layman's term compared to a simple room pero hindi, but with asymmetrical geometry. Ito yung pinaka-common na sitwasyon talaga in terms of study of acoustics. Okay. Therefore, we also need to check the room geometry. Of course, as what I've said, the shape of the room defines the movement of the sound waves within the room. Okay? And relating to, if we will consider the acoustic treatment, which is the job of acoustic engineers or acousticians, the placement of acoustic materials should be determined by the way the sound moves in that particular room in order to ensure optimal efficiency of the materials. So yun yung pinag-aaralan talaga nila. But for us, the sound system designer, kailangan din nating nalaman to in preparation of designing a system. So the collaboration here between the sound designer and the interior designer or architect or acoustic engineer is exchange of details. For example, when we design a system, meron talaga mga tatamaan ng walls, floors, and ceilings. Uh, yung mga ganong details, we need to share with the architects or the acousticians para ma-determine nila saan talaga yung ititreat na part ng room. Of course, if the owner cannot afford to overall treat the room, which is very costly, okay? So this is now the collaboration between the sound designer and the architects or acousticians, okay? So, number one is respect the architecture of the space. So therefore, first, let's check the various room shapes, sound behaviors inside these rooms, okay? In order to consider and respect the architecture of the room. First, in terms of sound distribution. So, when we do site inspection or evaluation of the room, for example here, in this figure, makita natin kaagad na ito yung possible na mangyayari. Meaning, the sound source will be coming from here. There will be several reflections, short reflections, and then may mga marami pang reflections sa walls, sa ceilings, going to the back of the venue. And then there's a shadow here. So, mahirap i-deal. So, at the design point of view, at least alam natin or at least nire-respeto natin yung architecture ng room because this will affect or this will guide us in designing the proper sound system. Next consideration is the seating arrangement. Okay? Pag-check natin sa site or sa floor plan, is there direct line of sight and hearing? So, kailangan natin itong i-check. And then, when it comes to raised stage or sloping stage, kailangan din itong makita because this can improve the direct sound to the audience from the sound source if we're going to place a speaker here. Okay? That's on the seating arrangement, which is another factor. The next factor is the reflection. So there are two types of reflections, the useful and the harmful. First, the useful. For this one, for a rectangular room like this, alam natin na this would cause useful reflection dito sa part na to because reflection can also enhance or reinforce a sound at certain level. Okay? At certain level, which we'll be discussing later on. And then for modified ceiling profile or room like this, makikita natin na pababa na siya konti. This area here has also useful reflection. So, looking at this room, makikita natin kaagad na magagamit natin yung reflection in terms of designing a sound system. Next part is the problematic reflection. So, upon seeing this type of room, makikita natin kaagad na there will be long reverberation or echo, long echo from this area here. So, ito pa lang, alam natin kaagad na malaking problema ang kakaharapin natin in terms of designing a sound system in this particular room. So, relating to the acoustic treatment job, nilalagyan lang dito ng mga reflector and diffuser. So that's their direct approach in terms of treatment. This is just the basic approach, but acousticians and acoustic engineers, they will really have a careful study and several measurements of the room before coming up with the design. But for a direct approach, kung titingnan natin kaagad, alam na natin kaagad na ito yung may mga possible na problems. Itong areas na to. Okay? And then, furthermore, okay, ito yung, upon seeing this venue, ito yung mga, kumbaga parang common type geometry ng auditorium nowadays. Kung mapapansin nyo, meron silang mga nilalagay dito ng mga panels, okay, sa ceiling. Okay? And then may mga nilalagay din sila ditong mga absorbers sa likod ng room. Okay? So, upon seeing this type of room, makikita natin agad na ito yung behavior niya. At least man lang. But if we want to really evaluate the behavior of the sound in this particular room, we need to consult a acoustician. Okay? For the basic hall configurations, ito yung common na mga halls. So we need to study all of this. We need to check all of this para when we encountered this type of venue in our projects, alam na natin na more or less ito yung possible na mga may encounter natin. For this rectangular basic hall, ito yung pinaka-basic. Okay? So there will be cross reflections between parallel walls. Ito kagad yung ma-experience natin. And then the sound can be reflected from the real walls back to the stage. So dito nangyayari yung sinasabi nilang slap back. Okay? So pag nasa stage area ka, pag nakaupo ka sa harapan o sa gitna, pag ikaw audience, okay yung tunog. But when you're standing on the stage, lalo na kung ikaw yung speaker or performer, marinig mo kaagad yung slapback o yung balik, yung sinasabi ng balik ng tunog. With this type of hall, rectangular type. Ito yung pinaka-common. Hindi ko naman sinasabing nangyayari ito sa lahat ng mga halls, but ito yung talaga yung pinaka-common na scenario. Unless treated yung mga halls. Next part is the fan shape, which is ito din yung kung common tong rectangular hall, mas common tong fan shape halls. Okay? Ito mas maganda to dahil the walls are non-parallels. Okay? So parang nagiging diffuser tong mga left and right sides or walls. Okay? And then the last part, horseshoe, ito naman yung pinaka-common design ng mga opera houses or concert halls, lalo na abroad. Ito yung mga common na design. Okay? So, these are the three basic hall configurations. Now, let's go to sa mga rooms naman, yung basic rooms. For narrow rooms, so we will be relating this study or evaluation into the application of acoustic treatment. Kasi alam natin na kung may problema talaga, hindi natin kailangan mag-design ng system, but we also need to discuss with the owner of the project to talk to the acoustician. But by knowing the geometry, we have an initial discussion with the owner and the acoustician kung ano yung possible na problem, knowing these behaviors. So with these narrow rooms, alam natin na we need to place absorbing materials on the ceiling, in the part here. Okay? Okay? And then sound absorbers must be placed as close to the sound source as possible. Dahil narrow nga siya, yung mga absorbers kailangang mas malapit sa source. So ito yung isa sa mga basic na kailangan natin gawin. Next type of room is round rooms. Ito naman hindi masyadong common. But the behavior of this particular room is that the sound moves towards the constructive center. So papunta sa gitna. May mga venue tayo dito sa Pilipinas na ganito yung parang orientation niya. So that's why they need to treat yung ceiling para hindi bumabalik yung sound going to the center. Okay? Next, large rooms with low ceiling. Malaking room, mababang ceiling. Okay. So, in large rooms, the sound spreading is experienced at the greatest challenge. Okay? So, since the speech can be heard over long distances, okay? And then, sound absorbers can be applied to the ceiling. Kailangan ma-treat yung mga ceiling kasi nga masyado siyang mababa. Okay? And then, the sound regulation from the floor is secured with furniture. So, at least kung absorbent yung mga furniture, pwede rin siyang magiging, pwede rin siyang makatulong sa pag-absorb ng reflection ng room. So, this is the characteristics of a large room with low ceiling. Large room with high ceiling, it's difficult to consider due to the relative high noise level. So, mataas ang noise level pag high ceiling siya, of course. Maraming mga factors dyan. Or when you have reflections in that particular room, marami siyang space na pagdadaanan ng reflection. So, kailangan nating pag-aralan mabuti kung paano yung treatment ng room, and we also need to consult an acousticians. Okay? For small rooms with parallel walls, ito yung pinaka-common nangyayari sa atin. The low frequencies often seem to be predominant, making the space appears to be consistently primarily of humming sound. So parang kung sa maliit na room lang with parallel walls, yung boses natin parang nag-hum. Why? Humming of low frequencies dahil nga low frequencies have parang longer bandwidth, yan kagad yung predominant sa particular room. Kaya parang pag kulob siya, parang sinasabi niyang kulob, malaki or mabalon yung tunog naman. So that's the characteristics of a small rooms with parallel walls. Next, ceiling domes. Ito yung one of the parang problematic geometries na na-encounter natin, lalo na sa mga Catholic churches na mga ceiling nila, mga dome type talaga. Okay. So, ito yung one of the challenges na may encounter in designing sound system sa mga Catholic churches. Na ganito yung room geometry. Next, type of room with inclined ceiling. Okay. With this type of room naman, it has a sound spreading and sound concentrating effect. So, medyo mahirap din i-deal. Mag-spread and then mag-concentrate. So, we need to carefully study the acoustic of this particular room. Okay? Next, inclined walls. Okay? Same issue with inclined ceilings. It has the sound spreading and concentrating effect. Okay? So ito yung mga pinag-aaralan. In general, suggestion by the study of acoustics, the walls inclined by more than 6 degrees ensure an excellent sound diffusion. So the most effective diffusion is obtained by applying several angles. So minsan, ang ginagawa ng iba, kung naka-incline siya, naglalagay pa silang treatment na naka-incline din as para siyang gagamitin lang sound diffuser in this particular room. Next is vaulted ceiling. Ito yung mga common sa mga hallways, common din to sa mga venues. So the characteristic here is that the sound is concentrated in the constructive center of the room. Okay. And then the sound movements also appears stronger along the curve. So when we see this particular type of room, alam din ng kagad natin na kailangan talaga nating i-treat tong particular ceiling. Yung ceiling of this particular room. Another type of room, ito yung pinaka-common sa mga venues, auditoriums, which is rooms with mezzanine. So ito medyo mahirap tong i-deal because It has a long reverberation time problem and then another shorter reverberation time problem because of the wall and ceiling and then because of the mezzanine. So ito rin yung mahirap i-deal when it comes to applying acoustic treatment. Okay? And at the same time, medyo mahirap din itong i-deal in terms of tuning and calibrating ng sound system. So kailangan talagang i-analyze mo yung behavior ng sound in this particular type of room. Okay? So these are just the basic types of rooms that you also need to consider in respect to knowing the room geometry. Okay. As we have said, the number one objective is to respect the architecture of the space. Okay. So this first objective is the somewhat we call this parang ito na yung parang pinaka diplomacy in terms of dealing with the architect, interior designer, and building owner. Ito yung meron talagang interaction with the human na involved dito. Because the next part here is the technical part of the design. Ito na yung parang actual na action talaga ng design. The first one is the interaction with the personnel involved in the project. This one is in the perspective of the designer. So this is to distribute direct sound evenly to the listening area. Importante ito. Okay? We need to discuss the basic tools of sound system design. Okay? Which is the first one is the room acoustics, which is we have discussed yung basic lang. Second one is the loudspeaker selection, placement, and orientation. And the third one, last one, is the selection of electronic component. So ito yung tatlong components talaga. The third one, ito na yung pagpipili natin ng mga equipment from the microphones, mixers, amplifiers, which parang has several factors to consider. Mas mahal, mas mura, microphones with different applications. But with our discussion today, we'll focus on this one. The second part, which is loudspeaker selection, placement, and orientation. Okay. Okay. For the loudspeaker selection and placement, the proper setup and loudspeaker placement are crucial. Of course, sabi nga ni Engineer Bai kanina, we need to reach the audience and we need to deliver a clear and loud message to the audience. Maybe it indoor or outdoor or different venues. Okay. And then, loudspeaker placement is very important in terms of designing a sound system. Ito talaga yung first part ng sound system design. Because the other components of the system, yun na yung pwedeng pag-aralang mabuti. Like for example, yung microphones, kailangan mo ng wired, kailangan mo ng wireless, kailangan mo ng head-worn. Yun yung maraming mga variations. But for the loudspeaker placement or loudspeaker choice, ito talaga yung sinasabi lang, there should be no compromise. Or else, hindi mo talaga masasatisfy yung tunog na gusto mo sa isang venue. Okay? So, there are 5 loudspeaker system configurations. Actually, before, this is previously 4 lang. But as the time evolves, may mga technology na lumalabas ngayon, which is later on we will be explaining, naging 5 siya. So the first one is the left-right or the stereo configurations. Ito yung pinaka-common. Ito yung selection and placement ng loudspeaker. Left-right, pinaka-common. O sinasabi lang stereo. Next part is the center or mono. Um, Nowadays, marami pa tayong siguro mga makikitang ganitong application. Most especially yung mga sinaunang cathedral or Catholic churches. Ang design kasi talaga before is a center cluster a system. Ewan ko kung meron pa ngayon, but ito yung common design before. Okay? And then, there's a left, center, right configuration. So, this is applicable in the venue na malapad siya, na hindi maaabot ng coverage ng speaker yung center. Okay? At the same time, ito rin yung ginagamit ng mga venues na may mga play, stage play. So that they can, in terms of sound mixing, they can pan left, center, yung effect ng boses ng mga performers. For example, when the performer will be coming out from the left part of the stage, of course mas malakas yung tunog ng left cluster. Kung maglalakad siya papuntang right side of the stage, susundan ng panning ng sound engineer yung tunog niya parang nag-shift from left to right. So this is more on the artistic part of the mixing. So kaya ginagawa na itong left, center, right. Another application, sometimes sa mga orchestra or musical presentations, minsan yung gusto ng director o gusto ng sound engineer na lumalabas yung boses lang sa gitna, sa center, and then yung mga music sa left and right. May mga ganun silang parang artistic approach in terms of mixing. At the same time, kailangan din yan so that the audience parang will experience the real parang play talaga. Nandun nang galing yung tunog sa left, papuntang center, papuntang right. So, they're implementing this part of the system. The next type of system is the distributed type. So, ito yung pinaka-common in terms of for designer and system integrator like us. Ito yung pinaka-common distributed system. So, we have here a main speaker. Mahaba yung venue. So, we'll be putting a fill or delay speaker here. And then, sa likod ng venue, may mezzanine. So, we'll be putting a fill speaker here. So, distributed. Distributed dahil hindi kayang i-cover ng main speaker yung buong venue. Another type of distributed system is for a venue like this. There's a stage. This is the flown main speaker. We have a side fill or a fill speaker. And we have here a delay speaker focusing only on the audience, on the mezzanine part for the audience here. And there's another fill speaker here covering the under balcony part. So distributed type. Another distributed type of system is the sinasabi lang CV or constant voltage system or the ceiling speakers for background music and PA system. So parang ito yon. So these are part of this, these are types of the distributed system. And ito yung sinasabi ko sa inyo kanina na the fifth part is the 3D or sinasabi nilang immersive hyperreal configuration. This is the future of sound reinforcement system. This is the future of deployment of loudspeaker system sa mga events. So this concept started in sinasabi nilang sa Dolby, sa Atmos. Ito yung sa mga cinemas. But in sound reinforcement, ito na talaga yung future. Okay? Several loudspeaker manufacturers, they've developed their own processors, technologies of this type of system. And they have been deploying, they have been using this type of system in concerts. Matagal na, mga 2 years na. Sa Pilipinas, wala pa lang tayo, but soon, pagkabalik ng industriya, o pagkabalik ng mga concerts, we'll be experiencing this type of system. So again, this is the future of sound reinforcement, the 3D system. If you want to check on the website here, this is one of the immersive system available in the market. Wala pa lang dito sa Pilipinas. Sa abroad, ginagamit nila ito. Not only for concerts, not only for, but also for DJs. Imagine DJs, gumagamit na ng ganito. Yung mga music DJs. Okay? So, you might be wondering, ano yung basic concept nito? Okay. So, this is how it is. In basic, discussion lang. So, before, yung left, center, right system, left, center, right, okay? You have here a coverage for the left and the right, and you have here, sinasabi nating specialized zone. Ito yung sweet spot. Ito yung pinakamagandang seat sa concert. Dahil dito mo may experience yung totoo talagang stereo image. Kung magmi-mix ng stereo, ang sound engineer, which is at this part here. So, kung manonood tayo ng concert, ito talaga yung pinakamagandang posisyon. Okay. With this with this situation, ito yung current situation talaga natin. Parang kung alam natin, pag-aagawan talaga natin yung spot na to. But ang pinakamahal na ticket is sometimes sa harapan eh. This part here, this part here. Okay? But kung alam natin, ito talaga yung pipiliin natin. What if may balcony? So, in short, yung coverage ng system with this left-right system, hindi siya balanse. Okay? Hindi siya balanse in reality. In reality. So that's why developers of this system, they come up with this concept. So, anong epekto nito? With these speakers, 1, 2, 3, 4, 5, 6, 7, 8, 9. At least 9 for this type of venue. Pwede ring 7, minimum of 7. Pwede ring 12 kung malapad yung venue. So this is parang pinaka-main speakers. These are effect speakers. And the subwoofer is here at the center. So meaning, with a special processor that can accommodate 1,000 channels, mixing channels, they develop an algorithm to have a specialized zone as wide as this one. Kumbaga, halos yung buong area parehas na ng narinig nung system ng LCR. This one, here. So ito, napakalapad na ngayon. Meaning, kahit saan kang umupong part ng venue, parehas talagang tunog. Kung nakaupo ka sa harapan, kung nakaupo ka sa gilid sa likuran, o sa mezzanine, o kung saang place ng venue. Okay? So, which is very, parang beneficial dun sa mga nagbabayad talaga ng mga tickets sa mga concerts. Okay? So, with this system, mamimix nila yung banda or performance here because they have several speakers here. So, ang main idea here is what you see is what you hear. Parang ganon. Meaning, if the guitarist is playing on this side of the stage, eto mo talaga siya maririnig. Okay? Dito mo talaga siya maririnig. Parang realistic talaga. You'll be immersed by the performers or by the sound of this particular system. Okay? So, yung performance dito mo talaga siya maririnig. But, if you're sitting here, ang marinig mo talaga, which is guitarist, from this speaker here. Parang ito talaga siya, dito talaga siya manggagaling. So, that's more or less the concept. What you see is what you hear. Ito yung concept nito. So, this is the future of the sound reinforcement system. Okay? In the future, we'll be seeing this type of speaker configuration. Before, left, right lang. Sorry. But in the future, ito na yung makikita natin nakasabit sa mga stage. Okay? Okay? So, interesting, yeah? So, we hope that we'll be experiencing this type of system pag nakabalik na yung mga shows dito sa Pilipinas. Okay. As a continuation of the loudspeaker selection and placement, meron tayong 4 guidelines. Okay? First off, keep reflected sound to a minimum. Okay? Second, get as much direct sound to the audience as possible. Third, get the level and tone as constant as possible. The last one, keep direct and reflected sound away from the microphones. Okay, we'll be discussing these 4 guidelines one by one in details. First one, of course, when we place a speaker, ilalayo talaga natin siya o iiwas natin siya sa mga walls. Okay? So that the reflected sound will be minimum. So in this case, as a designer's in designer's perspective, of course, we need to understand yung mga speaker dispersion. Okay? This is the horizontal dispersion and vertical dispersion. So later on, we can apply this knowledge because this is about speaker directivity. So when we understand, when we know the dispersion of the speakers, we will be guided kung paano natin siya i-mount to keep reflection as minimum as possible. The third factor is that we should know the characteristics of the speaker that will be designing in the venue. Of course, we know that column speakers will behave like this. Ito yung sound waves niya. We call this coplanar sound wave. And then, of course, we know that the point source speakers will behave this way. So, ito yung mga factors na kailangan natin malaman na column speaker ba ilalagay ko dito or point source speaker in terms of their behavior. And the third part is that we also need to review the behaviors, the properties of sound wave. This is the spherical sound wave, cylindrical sound wave, and then the planar sound wave. Kailangan talaga natin maintindihan to when we design a speaker system for a venue. For example, looking at this venue here, meron tayong nilagay na speaker which is not enough to cover the audience. Okay. Because of this, ang gagawin natin, we'll be putting another speaker, of course. So, the design will be like this one. One speaker plus one speaker. Unfortunately, pag hindi natin pinag-aralan yung behavior ng speaker or yung characteristics ng dispersion niya, we will overcome this problem. The speaker interference. Okay? So, meaning, hindi lang basta speaker ikakabit natin dyan because nowadays, meron pa rin kami nakikitang mga design and installation ng mga venues na ganito. Meaning, basta may isang speaker, tatabihan mo ng isang speaker, lalaki yung tunog or mako-cover yung buong area. That's yun yung parang concept eh. But without properly investigating kung ano talagang epekto nito. So ang epekto nito sa audience here, instead of receiving a clear message or voice or music, dito nagkakaroon ng problema because the interference. Hindi naman siya masyadong maintindihan yung message here. Meaning, hindi tama yung design mo ng speaker system. Okay? So, with this particular scenario, we also need to carefully select a speaker. a loudspeaker for a particular venue. So we know that we have three types of speakers: point source or coaxial. This is the point source, coaxial speaker, and then the point source here, and wall mount speakers and the ceiling speaker. So these speakers are part of the category of a point source or coaxial speakers. We have the line source or sinasabi lang line array, which is common for large venues, this one here. And then the column speakers. Of course, there are other types of speakers, garden speakers, horn speakers, but they will be falling under this category here. Okay, we need to carefully check the advantages and disadvantages of these types of speakers. First, for the point source, of course, we have versatility in size. Madali siya ikabit. Madali siyang ikabit na nakatayo, nakahiga. Madali siyang install sa mga venues, lalo yung sa mga under balconies kasi maliliit siya. Okay? Unlike these speakers here. And then, there's a pattern coverage. Okay? And then, there's a horizontal coverage, meaning, makikita natin kaagad yung horizontal and vertical niya kasi minsan, isa lang siya talaga. Kumbaga, straightforward. For this particular speaker, the horizontal coverage is 90 by, say, 60 degrees. So, kita mo kaagad. Unlike these speakers here, na marami pa siyang pwedeng variations in terms of the configuration. And of course, one of the advantages, affordability. Affordable yung mga ganitong types of speakers. Okay? So, upon knowing the advantages and characteristics of the speakers, maisip natin, ito ba yung kailangan nating ilagay sa venue? Or, do we need line source? Okay, for line source naman, advantages are these 3 points here. Walang drop-off with distance. Malayo ang bato. Because for line source, these are the elements of the line source. So kung dadamihan mo yung elements, maging directional yung speakers, so mas malayo yung bato ng tunog in layman's term. Okay? And then, for vertical pattern control. So, vertical pattern control, advantageous siya dahil pwede mo siyang i-vary in terms of the display angles of the speakers, and then kung paano mo siya babaliin, yun yung layman's term nila. So magkakaroon ng variations of vertical dispersion. Yun yung one of the advantages. Meaning, pag malaki venue, pag nakasabit siya, mas flexible yung vertical pattern ng line source. Okay. And then, SPL capability. Of course, mas higher SPL siya talaga. That's why this is used for larger venues. Dito naman, for column speakers, the main consideration is aesthetics. Ito yung gustong-gusto ng mga conscious or lalo yung mga architects or yung mga owners na medyo conscious dun sa architecture o sa interior design nila. Maliit lang na speaker, kulay puti, madaling i-blend sa walls. Okay? Yung iba pa, kino-conceal talaga nila, pinipinturahan para madaling i-blend. So that's in terms of aesthetics. Number 1, coverage. Why coverage? Because the main characteristics of these column speaker is that yung horizontal niya sometimes napaka-wide, ranging from 110 to 120. So, meaning, sa mga common design, isang speaker pa lang, malapad din yung kino-cover niya. And then, for the vertical dispersion, kung natatandaan nyo kanina, this line here, so ang dispersion niya is diretso. So, sometimes there are specs of column speaker na ang ang dispersion nila is 120 horizontal, 10 vertical. Meaning, yung 10 talaga, kahit i-double mo distance, wala pa rin siyang signal loss. dahil nga sa behavior ng coplanar sound wave. So ito yung sinasabi lang in terms of coverage, may advantage din yung column speaker. Of course, consistent ang sound level dahil yung sound wave niya diretso. Coplanar ang behavior niya. So diretso talagang 10 degrees mula sa harapan hanggang sa likuran. Okay? And then affordability. Of course, this is not as affordable as point source or coaxial speakers, but this is more is affordable than the line source speakers. Okay? So ito yung mga advantages. So knowing this advantages or characteristics ng mga speakers, makakapag-come up na tayo ng design ng speaker system in a venue. Of course, considering dun sa sinasabi natin o pinag-aralan natin kanina ng acoustic behavior, room geometry, and other factors ng room. What about disadvantages? Okay. For point source, ito yung mga disadvantages. Low frequency limitations to the pattern control. Meaning, low frequency, hindi siya masyadong, in layman's term, hindi masyadong malalim tumunog. Meaning, kailangan pa niya ng subwoofer for applications such as mga musical events. Okay? But for basic announcement system, sinasabi lang PA system, or for speech,
asawa mo ba yan, Sel?
okay?
Toilet.
So that's the limitation. Pag gagamitin mo siya sa mga application na may music, kailangan talaga niya ng low frequency extension or subwoofer. Okay? Then, arraying challenges. Ito yung sinasabi natin kanina na marami pa kaming nakikita pa rin sa venue na coaxial speaker siya na hindi siya arrayable in terms of property ng speaker or design ng speaker. Pero ginawa siyang array, meaning pinagtabi o pinagdugtong siya para lang ma-cover or lumawak yung coverage. Without properly considering yung interference ng dalawang speakers. So, hindi talaga siya pwedeng i-array. So, ito yung isa sa mga challenges sa kanya. Yes, tumutunog, but hindi yun yung tamang tunog ng venue. Ito yung mga common na nakikita namin ngayon sa mga venues. Throw distance. Throw distance is also disadvantage of point source speaker compared to line source and column speakers. Why? Because for a typical point source speaker, depende sa brand or depende sa specifications, but usually hanggang ano lang yan, say hanggang 10 to 15 meters ang efficiency niya in terms of throw distance. Meaning, beyond that, maririnig mo siya pero hindi na kompleto yung tunog. Wala ng high frequency. Pero from 0 to 15 meters, kung sinasabi yan yung efficiency niya, yan talaga yung maririnig mo na kompleto pa yung tunog. So, but 15 meters for a venue or mga mid to large venue, yun yung limitation talaga. So, may mga venue talaga na hindi mo pwedeng lagyan ng point source speaker. That's why, papasok na tong category ng line source type. For shallow rooms, ang line source, ito rin yung disadvantage niya. Dahil, yung linya niya, mahaba. Okay? And then, for height requirement, for line source, kailangan mo talaga ng height. Dahil nga, kung i-cover mo yung front to back of the audience of a mid to large venue, kailangan mo talaga ng mataas na mounting height. So, for venues na mababa talaga yung ceiling, hindi talaga recommended yung line source type. Unfortunately, may mga venue pa rin tayo nakita na ngayon na instead of using point source, ito pa rin yung ginagamit nila is a line source type na speaker. So, if you carefully evaluate dun sa particular application niya, instead of ito yung nilagay, sayang yung investment ng project because even though it's a line source, meaning yung isang element nito, mayroong particular angle na kino-cover. For example, here, itong tatlong boxes na to, ito yung angulo na kino-cover niya for a venue. Ngayon, pag gagamitin mo siya as sa maliit na venue with low ceiling, kung tatlo lang siya, this will behave as parang point source speaker, not a line source. So, mahal siya and then behaving like a point source. So, bakit hindi ka gagamit ng point source? So, ito yung unti-unti nating kumbaga kinokorek sa industriya ngayon na dahil nga line source or line array, uso siya ngayon, ito yung common na ginagamit para lang magkaroon ng line array yung venue. No. It depends on the type of venue and the height of the venue. Okay? So, doon naman, ang sinasabi lang natin na why invest on a line source na quadruple lang mahal versus the point source. Okay? So, gumamit ka lang ng point source. So, that's the way of understanding the properties of the speaker. So, which is part of the loudspeaker selection that would be considered by the system designer. Okay, sightlines. Sightlines, ito rin yung limitation. Kung wala kang mounting height, wala kang kumbaga available or enough na sightlines, hindi rin pwede ang line source. Huwag natin pilitin. Because you will be just wasting money on the investment of the speakers. Number 3, itong last part na disadvantage expense. Of course, mahal talaga ang line source compared to other speakers. Okay. So, last part here is the column speaker. What are the disadvantages of the column speaker? Ito yung sinasabing passive column aiming. Okay? Passive column aiming. Ibig sabihin, ito kasi mga column speakers ito, usually kasi ito nakatayo or nakamount lang to parallel dun sa mga walls. So, pag naka-parallel ka sa wall and yung sound dispersion mo is diretso, 10 degrees from front to back, hindi mo tatamaan yung audience. So, kailangan mo talaga siyang itungo. Pag itutungo mo naman siya, amang tendency naman yan, masyado siyang obstructive dun sa area, sa space. So that's why this is one of the disadvantages of the column speaker in the venue, which is called the passive aiming, column aiming. So, ang ginawa ng mga manufacturers ng this particular type of speaker, nag-develop sila ng beam steering technology. Meaning, kahit naka-mount yung speaker na to, parallel to the wall, electronically, may steer nila yung dispersion na magiging ganito. Pointing towards or directly to the audience. Yun yung mga beam steering technology nila na sinasabi ngayon. Na yun yung mga bagong, ito yung technology ng column speaker, but expensive. Okay? So, we need to weigh yung mga factors kung ano talaga yung gagamitin nating speakers, depende sa venue. For volume or level or sound level, limitado rin yung column speakers. Why? Because column speaker is composed of small drivers na sometimes naka-interconnect in parallel. For example, these speakers here. Minsan, dahil nga slim siya, ang driver niya is 3-inch or 4-inch lang, sometimes nga 2-inch driver lang, but 16. 2-inch times 16 ang, for example, ang component nito. Okay? So, limitado yung volume because of the size of the driver, which is 2-inch. But in terms of coverage, malapad siya kasi this is a line. So, parang ito yung 10 degrees, diretso talaga. But in terms of volume, limitado siya talaga. That's why This is one of the disadvantages of a column speaker. Bass output, of course. Dahil nga 2-inch lang yung driver niya, hindi talaga siya ganun kalaki tumunog. Yung frequency response niya is not as low as yung mga malalaking driver. Kaya lower talaga yung bass output. But for speech, for Catholic churches, for venues with just speech applications, pwede itong column speakers. Okay. And then lastly, disadvantage siya for shallow rooms. Okay? So, with this, knowing these factors, advantages, disadvantages of 3 types of speakers, makikita na natin or malalaman natin kung ano talaga yung proper speaker na kailangan talaga natin i-design for particular venue. Okay? Okay? So, going back dito sa main objective of keeping reflected sound to a minimum, we need to parang install speakers or design speakers off the walls and surfaces. So, for example here, ito yung orientation ng speakers. Of course, we know that spherical waves will behave this way. Ito yon. Ito yung vertical dispersion ng speaker. Alam natin na magbabounce talaga sa ceiling itong speaker na to. Okay? So this is the main problem. So knowing all those properties of speakers, yung point source, yung line source, and column speaker, malalaman kagad natin yung solusyon. So for this particular area, kailangan mo talaga ng line array speaker just to cover this part here without having the sound to reflect on the walls and ceiling. Okay? So ito yung one of the ways to keep reflected sound to a minimum. Unfortunately, marami pa rin tayong nakikita ng mga ganitong mistakes of speaker positioning. So, ang ginagawa naman ngayon ng mga manufacturers ng mga point source speakers, because this is affordable speaker, ito yung madalas na ginagamit, ini-improvise nila tong mounting position or mounting socket ng speaker nila na pwede siyang i-tilt na going downwards or going towards the audience. But not this type of orientation, which is causing reflected sound here and slap back from the back wall. Okay. So, another point of keeping reflected sound to a minimum, by reducing the level of sound, reflected sound, we increase the critical distance. What is critical distance? We have discussed this in a previous webinar. So this is just a basic illustration of critical distance. So the critical distance is this part here, wherein the direct sound is equal to the reflected sound. Okay, this area here. So, if we translate to a venue within the illustration here, ito yung critical distance. So, at this area here, the reverberation is negligible. Kung baga, mas dominante pa rin yung direct sound versus the reflected sound. Up to this point here, but from this point here, beyond going to this point here, and up to this point here, the direct signal is negligible. Okay. So, in increasing the critical distance with this part here, based on this formula, if we will increase the Q, or if the speaker has highest Q or directivity, meaning instead of 60 degrees yung vertical dispersion niya, for example, I'll place a speaker here, instead of 60 degrees yung vertical dispersion, I will look for a speaker which has narrow dispersion, say 40 degrees. So kung mas narrow yung dispersion niya, itong critical distance na to, pwede ko siyang extend up to this part here, covering additional audience in this part here. Okay? So ito yung mga consideration in choosing speaker. So pag alam natin na masyadong reverberant yung room na to dito, masyadong mataas yung reverberation, kung sakaling hindi talaga natin maipapatreat yung particular room na to, at least i-increase natin yung critical distance by using highly directive loudspeaker. Ito yung pinaka parang direct approach of a designer. But of course, kung kaya nating ipatreat yung portion na to in this particular room, mas maganda. Increasing more the critical distance. Which makes the reflected sound at least more or less negligible because the direct sound is more dominant in that particular area. Okay? So, in terms of critical distance, we also need to check the specifications of the loudspeaker. So sa mga manufacturers, meron tayong spec sheet. Makita natin doon yung horizontal and vertical dispersion ng speakers. So that's the basis of selecting a speaker. Kung gagamit tayo ng parang pinaka-direct approach in terms of designing a system. Okay? So that's more on the parang keeping reflected sound to a minimum. The next item is get as much direct sound to the audience as possible. Okay? So in this two illustrations here, kung naka-pole mount lang, kailangan talaga nating ma-maximize yung line of sight ng area in terms of putting the speaker, aiming the speaker from front to back. Kung naka-fly naman ng speaker, kailangan talaga nating ma-aim mula sa harapan hanggang sa pinakalikuran. Okay, mechanically. Kumbaga ito yung first approach natin. Okay? So, get as much direct sound to the audience as possible. Kailangan talaga natin i-direct. May mga nakikita kasi tayong design or positioning ng speakers na wala talaga dun sa audience. Kumbaga basta na yung speaker lang nakakabit dyan, kahit magre-reflect sa wall, basta lang may speaker, basta malay narinig na tumutunog, pwede na. Okay? Yan yung mga nakita natin sa mga ibang venues. So by correcting that aiming of speakers and focusing the speaker direct to the audience, mas ma-improve pa natin yung coverage ng venue. Next item is get the level and tone as constant as possible throughout the venue. So this is now about the level and the tone. So tapos na tayo sa items 1 and 2 in terms of coverage, in terms of minimizing reflection in a room. This part here is about the sound level and the tone as constant as possible. So hindi lang basta tutunog siya, hindi lang basta properly covered siya, hindi lang basta lesser yung reverberation niya, but constant yung tunog from front to rear. Dito minsan nagkakatalo ang mga several models or brand ng loudspeakers. Because some loudspeakers, yung efficiency nila from the front to the rear, hindi talaga siya consistent. Meaning, pagdating doon sa likod, tumutunog pa rin siya, pero hindi na siya balanse. Okay? So meaning, hindi na siya constant. So we don't want that. So as a designer, kailangan talaga nating constant and level and tone throughout the audience area. Okay? So that's why most of the designers nowadays are using simulation softwares, which will be discussed thoroughly dito sa later part ng session natin. Okay? So why do we need to use or implement simulation softwares? Of course, ayaw na natin nung parang trial and error. Okay? Ayaw natin yung kakabit natin ngayon and then pag mali siya o hindi pantay yung tunog, babaguhin naman natin. We don't want that. Okay? As a designer, from the start of or during the design phase, kailangan talaga nating pulido yung design natin. Of course, ayaw din nating, in terms of coverage, ayaw din nating masyadong malakas sa gitna. Now, sa gilid naman, hindi naman pantay yung tunog. We don't want that. So through the use of simulation softwares, makikita natin lahat yan. Yung coverage, yung sound pressure level, and yung frequency response. Which is yan yung talaga yung main objective in designing a good sound system. Okay? Next part. Okay, ito yung one of the parang common considerations. Keep direct and reflected sound away from the microphones. Okay? Important, of course, when we design a system, maayos na nga siya, but kailangan natin i-anticipate yung acoustic feedback. Okay? Dahil pag maayos yung sound system natin, maayos yung speaker design natin, and then properly covered yung buong areas, constant yung tonality from left to right, from front to back. However, pag ginagamit naman natin yung system, nagfi-feedback naman siya. So, we don't want that. So, we should design a system that is prone to feedback. So, it's either by positioning of the speakers properly na iiwas natin sa location ng microphones, or kailangan talaga nating i-tune ang system dahil kung hindi natin maiwasan nandun talaga yung microphone, we need to calibrate the system and eliminate feedback. Okay? Because as stated here, kahit nasa mababang ano na siya, below threshold feedback, nadidegrade pa rin yung direct sound and overall coherence ng tunog. So kung wala kang headroom, meaning konting adjustment lang o konting taas lang ng level ng system mo, may tendency na feedback. So wala kang peace of mind in terms of kung ikaw yung magmi-mix, ikaw yung mag-ooperate ng sound system, hindi talaga siya reliable dahil wala kang proper headroom. So, in order to avoid that, avoid or minimize feedback. Yan yung pinaka-message of this particular part here. Okay? So, let's go to the next objective. Provide adequate intelligibility. This is number 3. So, this part here, we'll be discussing about intelligibility. Okay? Hindi lang malakas, but malinaw. Okay. By definition, it is described as the ability to understand what is being said. Okay? Kung naintindihan mo talaga natin kung ano yung sinasabi or message ng speaker or ng performer on stage, for example. Okay. Again, I've said this many times. Sound quality and intelligibility are not the same thing. Iba yung maganda yung tunog, iba rin yung malinaw yung tunog. Okay. And as what I've said a while ago, audibility, yung pagkadinig, the ability to hear a sound is not equal to clarity. Okay? Okay. As what, again, sinasabi ni Engineer Bai kanina, na sound is all about communicating a message. Okay? And for this to be effective, ito talaga yung pinaka-importante. The message must be clear and intelligible. So malinaw siya and naintindihan. Okay. Okay. So nowadays, marami ng mga paraan o marami ng mga devices kung paano i-measure intelligibility. Ang significance nito sa part ng design is that we also need to know and at least calculate or know the intelligibility of our design prior to the application in the actual field. Okay? So, we need to know the factors affecting intelligibility. Okay? So, in terms of sound system bandwidth and frequency response, which is the highest and lowest frequencies a speaker can usefully reproduce. So, this is just the main guideline. For the sound system has to guarantee a response from 100 to 10K. Okay. So meaning, kailangan talaga yung sound system has a frequency response of 100 Hz to 10 kilohertz para maging intelligible siya. Okay? Ito yung basic lang. So, from this graph here, so this is from more or less 100 going to 8 and 10. So this part here. So in terms of frequency, ito yung voice frequency here. That's why, as a basic rule, kailangan talagang meron tayong frequency response na 100 Hz to 10 kHz. Okay. That's in terms of bandwidth and frequency response. For signal to noise ratio, okay, at least the SPL must be adequate and heard comfortably. So, for a normal conversation, this should be 7 to 90 dB. Okay. From the graph here, makikita natin to dito. This graph here. Furthermore, so, for the message or music to be intelligible, kailangan talaga yung signal to noise ratio is more than 25 dB. Okay. More than 25 dB. Meaning, why 25 dB? Because 25 dB, based on the standard, ito yung threshold ng hearing. Ito yung parang simula. At 25 dB, doon na simula makakarinig ng message or maintindihan ng tao in terms of hearing the message. Okay? From 25 dB. Okay. So, para intelligible siya, kailangan talaga more than 25 dB. Okay. And then, in terms of signal to noise ratio, yung noise kasi will mask direct sound and lowers intelligibility. Okay? So, in this situation here, dahil nga maingay siya, nababawasan yung signal to noise ratio niya, causing the sound or the message to not be intelligible. So, relating to this portion here, ang ginagawa ngayon ng mga designer, if you're familiar with sound masking, ito na rin yung technology na in-implement nila. lalo na yung sa mga facilities na kailangan ng noise masking. So in principle, sa mga area na medyo maingay talaga, noise masking, nagge-generate siya ng system na nagge-generate ng noise to mask the noise for the message to be heard clearly and intelligible. So yan yung technology na ngayon. Marami na rin mga system ngayon na actually marami na rin gumagamit ngayon dito niyan. For example, yung mga call centers. Gumagamit na rin sila ng mga ganyan technology. So that's on the SNR, the signal to noise ratio. Next, in terms of room reverberation. So these are the factors affecting intelligibility. Okay. Long RT60s. Of course, alam na natin, kung masyadong mahaba yung reverberation, hindi na intelligible yung sound. Okay? Next, late reflection. More than 50 milliseconds. Okay? Parang nabiblur na yung direct speech. Okay? With late reflections. Early reflections, which is less than 35 to 50 milliseconds. With this reflection time, ito yung nagre-reinforce. So as what I've said a while ago, hindi lahat ng reflections harmful. May mga reflections din na useful in terms of reinforcing the sound. For example, dun sa figure na pinakita ko kanina, may mga venue talaga na kailangan ng mahabang reflection, lalo na yung mga musical, may mga music applications. Okay? Just to reinforce the dynamic range of music in a venue. But for speech, hindi talaga siya applicable pag mga long reflections. Okay. Next, in terms of distortions. Okay. Distortion is one of the factors affecting intelligibility. Okay. Ito yung mga signal clipping, intermodulation, and acoustic distortion. Signal clipping, one of the main or best example is that yung baka nagpipik na yung speaker, nagka-crack na yung speaker dahil hindi talaga niya kaya yung tunog or hindi niya kaya yung frequency na pinapalabas mo sa speaker system. So, this boils down to selecting the proper speaker that you need to design and install in a venue. Para hindi magkaroon ng distortion o signal clipping, kailangan mo talagang pumili ng maayos na speaker. So, you need to check the specifications of various items. Hindi lang speaker, but sometimes the microphone, hindi niya kayang i-handle yung matinis or mataas na boses ng singer, nagka-crack na siya, causing signal clipping, causing distortion, affecting dito sa intelligibility ng music and speech. Okay? So, these are the factors that affects intelligibility. Ngayon, meron tayong parang criteria. We have this criteria to optimize speech intelligibility. Number one, of course, we've discussed this already. Aim the loudspeaker to the listener. Okay? Pinag-usapan na natin ito kanina. We need to direct the loudspeaker to the listener. Of course, we need to provide direct line of sight between loudspeaker and listener. With this, maximize natin yung coverage ng speaker, maximize natin itong speech intelligibility. Number 3, ensure adequate bandwidth. This is in terms of frequency response. So dapat talaga yung system mo is capable at least to handle 100 hertz to 10 kilohertz na frequency response or bandwidth. Number 4, this is in terms of the acoustics of the room. So let's avoid lalo na itong mga problems in terms of subwoofers, bass frequencies. Dahil yung may mga rooms talaga na natatrap yung mga bass frequency, so which has wider bandwidth, yan talaga yung mahirap i-deal in terms of getting intelligible sound. Okay? So let's avoid that. Meaning, kung kaya nating i-treat yung room and by deploying bass trap, yung sinasabi ng bass trap, so mga corners o sa likod ng venues, we should implement that. Number 5, implement distributed speaker system if possible. Okay. So, kung hindi talaga with a room with the reverberation problems, kung hindi talaga kaya ng main speaker lang deployed in front, kung hindi talaga kayang ma-cover yung buong room, let's consider implementing distributed system. Meron tayong main speaker, meron tayong delay speaker or fill speaker. Okay? If possible. But ang limitations kasi dito, sometimes yung mga room, wala talaga siyang paglalagyan ng for example, yung mga high ceiling na rooms or venues, wala talaga siyang paglalagyan ng mga delay speakers sa bandang gitna, focusing or covering the center part up to the rear part of the venue. So yun yung limitation. But if you are allowed to implement distributed system, mas maganda. Meaning, meron tayong zoning ng signal. Main speaker will be concentrating or will be focusing only from front to the mid section of the venue, and the delay speaker will be covering the mid part up to the rear part of the venue. Distributed system. Okay? Of course, increase sound the SNR to more than 10 dB, which we have discussed. Another item that we've discussed, we need to use speakers with high directivity or Q, most especially in reverberant environment. Okay. Number 8, minimize SPL variations. What do you mean by SPL variations? In a reverberant venue, meron kasing, so reverberant na siya, that's the existing problem of the venue. And in addition to that, meron tayong mga material or ang application talaga natin has SPL variations. Humihina, lumalakas, humihina, lumalakas, causing different types of reverberations. So, kung ang direct solution nito, if you know that your venue or your room is has reverberation problems, at least you minimize the variation of SPL. Kung ito lang talaga yung level mo, ito yung lakas ng system mo, hanggang dito ka lang talaga. Or you need to control the level of the speaker or the performer. Hanggang dyan lang siya talaga. Hindi siya pwedeng basta-basta na lang mag-vary ng level ng material niya. Or else, you will really lose speech intelligibility. Lastly, improve RT and acoustic environment. Okay? So, of course, we know this. We can improve the RT60 of the acoustic of the environment by deploying absorbers, and diffusers or acoustic treatment. Okay? Then, how do you measure or predict intelligibility? So there are several index or measurements. The first one is what they call ALCONS, or the percentage articulation loss of consonants index. So with this uh, measurement, ito yung sinasabi nila na in terms of lost consonants in the talker-listener path. Loss of consonants. Okay? We should take note here that vowel range is from 250 to 500 hertz, which carries power. Okay? 250 to 500 hertz, which is the low mid frequency, carry power. Okay. For consonants, range from 1 kilohertz to 4 kilohertz, which is the high frequency, carry information. Okay? For the consonants, from 1K to 4K, carries information. So ito yung mga kailangan nating tandaan in terms of designing a system. Minsan kasi, in terms of tuning and equalization ng system, hindi na natin kinoconsider tong mga frequencies na to. Ito yung usually natatanggal na frequency. Dahil nga, minsan sa mga venue, within this frequency range, nandito yung feedback. Okay? Nandito yung mga feedback frequencies na sinasabi nila. So, in terms of sa equalization, minsan, dito natin nakakatch yung mga frequency, which is important for the information and power of the speech. So, instead of equalization, you need to treat the room instead of applying equalization just to minimize the feedback within these frequencies. Yan yung tamang approach. Okay? Lost consonants equals lost intelligibility. Okay? Consonants. Ito yung importante because this carries information. Okay. One of our mentors in the audio engineering, ito yung lagi sinasabi niya, na Tagalog is the most intelligible dialect in the world. Why? Because Tagalog language, with Tagalog language, okay, or dialect, ang ratio ng vowel sa consonant is more or less 1:1. For example, naririnig nyo ba ako? So, doon pala makikita natin na ang ratio ng vowel and consonants is more or less 1:1. So, it has the power and the information. So, yung mga itong dialect natin and other dialects na maraming consonants, yun yung mas intelligible compared to other languages. Mas mahirap yung iba. For example, Russian language or yung mga ibang languages na maraming consonants, mas mahirap maintindihan in terms of or in a venue. Lalo na pag hindi mo na i-design na maayos yung system. Okay? So, this is the formula in getting alcons. But the important message here is that for this particular type of measurement of intelligibility, the 3 to 0% is the excellent part. Good is at this point here. Okay, that's the first measurement. Another measurement which is commonly used is the STI and RASTI, Sound Transmission, Speech Transmission Index. So, dito naman, ang ginagamit nila, instead of voice, in using Alcons, this one is the high frequency noise. Ito na yung ginagamitan talaga natin ng mga STI reading hardwares. Okay? So, for STI reading, it varies from 0, which is no intelligibility, to 1, which is perfect intelligibility. So this graph here shows the relationship of Alcons and STI. But for STI, at least at this point here, fair from 0.45 to 0.6 in terms of Alcons, that's 15 to 7%. So this boundary here is fair. If we can get a STI reading in terms by using equipment at this area here, is very good. Much more if we can get this reading here. So, in terms of STI and Alcons reading, we have come up with this parang defining limits of measurement, which is the CIS. This is the common scale to simplify the limits of acceptable intelligibility. For the EN 60849 standard, CIS should be more than 0.7. But in terms of the standard here in STI and Alcons, for the STI reading, the accepted standard here is 0.5. This is what we've been using in testing the performance STI reading of mostly fire alarm system, because this is based on the NFPA 72 standard, the 0.5 STI reading. For Alcons, it is 12. But for us, which is common, for us integrator, we are targeting this reading here. This is also the basis of some consultants worldwide in designing their own system. This is about the STI and RASTI and Alcons. Okay. So next part is topic number 4, which is the fourth objective: deliver sufficient level, frequency response, and natural sound quality for intended use. So we've been through with the level or SPL or sound pressure level in our previous objectives. Frequency response, we've discussed this already, and then we will focus this objective number 4 in discussing about natural sound quality for intended use. Okay? Hindi lang natural sound quality for whatever purpose, but the most important part here is for intended use. Saan ba siya talaga gagamitin? Natural sound for what? Okay. So, in terms of achieving natural sound for intended use, we need to evaluate the source material. Of course, we said that speakers are not all designed to do the same job. So, iba-ibang speaker, iba-ibang application, iba-ibang trabaho. Okay? So, first part, we need to analyze the source material because this will tell us the type of system that we need. Ano ba yung material mo? Speech, music, voice effects. So we need to analyze that para malaman natin kung ano talagang type ng system na kailangan natin. In terms of frequency response, we need to know the material because we need to know the frequency response and whether that frequency response suits the intended source content. Okay? Are your speakers need to be full range or for music delivery? Or like as what I've said, for human voice, for sound effects, etc. Okay. Third part, we need to determine also the type of content. And because this will also determine the speaker or the SPL of the speaker that we need for the type of the project that we are catering. Okay? Therefore, we have these basic guidelines in sound system applications, just the basic one. First part, this is in terms of application of sound system. This is just a parang summarized points, but there are several points when we discuss about certain system. But for this one, we need to just discuss on the basic part. For life safety evacuation system, which is regulated by NFPA 72 or the National Fire Protection Association, for this type of evacuation system, it should be at least 12 dB above noise floor and ideally 20 dB, but not to exceed 120 dB SPL, which is very loud. So the main point here to remember is that at least 12 dB up to 20 dB. This is according to NFPA 72 standard. For quiet environment, it should be at least 85 dB and has headroom of 20 dB according to NFPA standard. This is for the first type of system. So these are just the two basic guidelines. For another type of system, which is background music or BGM system, at least within the range of 65 to 85 dB, depending on the venue or the type of application. Meaning, background music of hospitals is more, the SPL is more lower compared to the BGM system in some venues like hotels, hotel lobbies, and other venues. Okay. But at least within this range. Wala pa tayong nilabas or wala pang any organization standardizing this particular system in terms of SPL and SPL setup. Dahil iba-iba. Tsaka iba-iba rin yung nakikinig. Third type is the vocal delivery systems. This is just a general description, but vocal delivery is more on, is both speech and some, for example, stage plays, preaching of head of churches. So this is categorized as vocal delivery systems. Okay. So the baseline is 85 dB. So knowing this basic guideline, for a designer, at least you will know that your system should perform at least 85 dB SPL. Okay? And then, in designing a system, we should always aim at least 12 dB just for vocal delivery headroom above the noise floor. So these are the two figures that we need to carefully bear in mind. 85 dB and at least 12 dB of headroom. for vocal delivery systems. But sa situation natin dito sa Philippines, since wala pa tayong mga regulations talaga, minsan hindi to talaga nasusunod. Especially this type of system. Ito yung amplified concert system. So this is ranging, the SPL is ranging from 100 dB to 120. Ito malakas talaga to. 100 dB to 120 dB. This is too loud. But why they need to design a system with this range is that because also of the noise floor. Nagsisigawan yung mga tao up to 80 to 90 dB. At least meron siyang 20 o 25 dB na headroom, naririnig pa rin siya. Okay? Naiintindihan pa rin siya. So that's why they need to design a system performing up to 120 dB SPL for amplified concert or concert system in general. And of course, it will depend on the type of artist or bands. Minsan, kung light music lang pinaperform ng bands, hindi mo kailangang pumalo ng 120 dB. But for rock bands, kailangan mo talagang i-consider itong 100 dB to 120 dB SPL. Just so that we have an idea, in USA, concert systems are designed to deliver up to 120 dB SPL throughout the venue. Ito talaga sila. Ito yung requirement nila. Meaning, ito talaga yung kailangang masunod ng kumbaga design. In Europe naman, because of the strict noise laws, they only specify up to 100 dB SPL only. Okay, so for amplified concert system, although we have several guidelines in the Philippines, in USA, in Europe, but another considerations that we also need to take note is that what kind of experience audience needs. So, ano ba talaga gusto ng audience? Gusto ba talaga nila na talaga the seats are rattling? Or gusto talaga nilang malinaw lang yung boses? Just, madinig lang yung speech. So, these are also other considerations. Although we have these parameters here, we have these basic guidelines, but we also need to consider this one. And more importantly, we also need to consider that this thing, what we call SPL dose. Your air can take just much SPL. Lalo na pag mga may mga may mga nagkakaedad na. So, but with this guideline, with this SPL dose, ito yung mga parameters of certain venues or environments. So, nandito na yung noisy restaurants. So, ito pala, ang sinasabi nila, noisy restaurants, nasa mga 85 dB. Okay. But, at this range, 100 to 110 dB, okay, the maximum exposure of this type of SPL should be 15 minutes max, or else magkakaproblema ka talaga sa hearing pag tumatagal. This one is really loud. So, protect and prevent. So at 85 dB, which has a tendency that will cause you hearing loss, kailangan mo na magsuot ng mga protecting devices, ear muffs, headsets, para mapangalagaan yung ating ears. So, in summary, we also need to carefully identify or evaluate the level of SPL that we should design or we deserve to hear in several venues like these venues here based on this graph. Okay, so we will go to the next objective, the fifth one, which is leave the listener with the sense that the sound is coming from the source. So this is more now on the area of perception of direction. Meaning, in particular application, pag yung nag-deliver ng message or music nasa stage area, the sound should be coming from the stage area, not at the side of the venue dahil doon nakalagay yung speaker mo. So that's not the concept here. The concept is that kung nasaan yung mag-deliver ng message, doon talaga dapat manggagaling doon talaga dapat yung direction ng doon talaga dapat manggagaling yung tunog. Okay. Let's take note that in a reflective area, the first arrival sound determines the perceived direction. Meaning, pag may narinig ka kaagad from the direct sound, the human here will recognize that as yun talaga yung nanggagaling yung direction. Doon talaga nanggagaling yung source. Even though we hear another sound, which is a reflection, arriving late and even louder, but with the first arrival of sound, na-identify na natin na doon talaga nanggaling yung tunog. That's the character of human hearing. That's the perception of direction. Okay. So, in a reverberant room, in a normal design practice, control the time of the second arrival so that it occurs about 5 milliseconds after the first. Meaning, so kung within kung up to 5 milliseconds lang yung first arrival ng voice, kahit reverberant yung room mo, okay pa rin siya. Naiintindihan pa rin. But beyond 5 milliseconds, kung mas matagal dyan, hindi mo na mapiperceive yung direction or yung pinanggalingan ng source. So, let's keep in mind of this one. 5 milliseconds. So again, yung room mo, reverberant, pero kung makontrol mo yung first arrival sa second arrival ng within 5 milliseconds, maintindihan mo pa rin, saka nandun pa rin yung perception mo about the direction. Okay? So, this phenomenon, which is perception of direction, is, of course, affected or relative to level and time delay. That's why in this graph here, you should target this one, this area here, which is good in terms of designing a system. Okay? So, kung reverberant yung room natin, and we cannot really force to just have one speaker in front, we have this system that can be implemented. The main plus delay or field speaker design. Meaning, since reverberant yung room mo, magkakaroon ka ngayon ng zoning ng coverage. The main speaker will cover this zone. The field speaker will cover this zone and this zone here. Okay. So, saan ngayon, paano natin ma-maintain yung perception? Na yung signal source from here is perceived to be from here dito sa mga nakaupo dito. Okay? na dahil ito yung naririnig niya. Okay? So, this in terms of tuning and calibration, ang kailangan talagang i-apply dito is tamang time delay alignment ng mga field speakers here in terms of or with respect to the location of the main speaker here. So by deploying properly calculated time delay dito sa speaker here, you can maintain the perception of the direction. If you're seated here, you can still maintain the perception of the direction that the signal source will be coming from here. So ito na yung part ng calibration and tuning ng buong system. Also here. So proper time delay setting should be applied in the speaker here to maintain the perception that the signal or the main source is coming in front or mainly from the main speaker in front. Okay? Okay. So, another important thing to remember is that the delay speakers will help, of course, localization. Kumbaga, ito yung sinasabi ko kanina na naka-per zone ang coverage niya, naka-localize siya, but with proper delay setting ng speaker. Okay, another important to remember here is that the delay speakers provide a smooth transition. So imagine kung nakaupo ka rito, kung hindi naka-properly time align, saka kung wala kang speaker dito, at saka kung hindi naka-properly time align to, kumbaga ito yung maririnig mo, pero yung eyesight mo o yung pagtingin mo nandito sa tao na nagsasalita. So there will be a parang hindi coordination between the eye and the ears. Dahil ito yung naririnig mo, nandito yung nakikita mo. Dito mo nakikita yung source ng tunog. So again, kailangang properly align itong mga delay speakers in respect to the location of the main speakers here. Okay? That's the perception of the direction. Another area that we need to take note is localization. Okay. Localization provides a more natural and comfortable listening experience. Related sa sinabi ko kanina, kung dito sa side mo narinig yung speaker, tapos yung signal source, tinitingnan mo sa harapan, wala ng coordination of your two senses, which is the listening and hearing. So, hindi siya properly coordinated or nakasync. So, in the long run, that would cause you parang fatigue. Dahil in the normal situation, hindi naman talaga yan yung nangyayari. Kung saan, without the sound reinforcement, kung may taong nagsasalita, kung saan mo siya nakikita, doon talaga manggagaling yung boses. But with sound reinforcement, kung baga, pag yung speaker mo narinig mo galing sa taas, tas yung source ng message is galing sa harapan, disoriented na yung senses mo. So hindi mo lang mararamdaman bakit masakit yung ulo mo. Kung kung uma-attend ka ng mga long sample, mga events with long speeches or sa church, mga long preaching, nararamdaman mo na lang parang hindi ka ease, parang may fatigue. Dahil yun sa disorientation nung hearing and eyesight mo. Okay? And then, let's remember that the sound by nature is in three-dimensional. So hindi lang left and right, meron pa rin siyang top and bottom. Okay? So, kailangan itong consider in terms of sound system design to have a more natural and comfortable listening experience. Kung hindi naka-localize, parang hindi nakasync yung senses mo, hindi ka comfortable. Okay? So this is the fifth objective of the sound system design. Next objective, control feedback at the microphone positions. Okay? Ito yung sinasabi natin kanina na maayos nga yung pagka-design ng system but hindi mo naman eliminate or at least control ng feedback, useless din yung system na dinesign mo. Okay. So, as written in several books, ito yung basic way or standard way kung paano mag-control ng feedback. There are other ways but ito yung pinaka-basic way. So, move the talker closer to the microphone. Meaning, kailangang ilapit yung nagsasalita, yung bibig ng nagsasalita or talker dun sa microphone so that you have a higher gain going into the system. Hindi mo na kailangang magtaas pa ng level ng speaker causing unwanted long reverberations affecting intelligibility and clarity of the message. Okay? And then causing feedback dahil pag bumabalik talaga yung tunog, napipick up ng microphone, causing signal loop, and when the gain of the microphone and speaker comes to unity or zero, that's the signal loop begins or the acoustic feedback. Okay? Second is select a directional microphone. So, instead of using omnidirectional microphone, you should select a directional microphone and give it to the speaker, okay, to control feedback. Number 3, use, of course, ito na naman yung sinasabi natin na gumamit tayo ng directional loudspeakers. Not only to minimize reverberation, but also to control feedback. So kung mas directional, hindi mas wide, hindi mas napipick up ng microphone, which can possibly cause feedback. Okay? So, another one. So, items 1 to 3, these are procedures or steps in controlling feedback manually. Item number 4 is using electronic. So, use equalization, compression, compressor limiter, and other electronic techniques, feedback suppressor, feedback eliminator, or other equipment to control feedback. So this one is by using electronic equipment. Ito yung, but we should take note here that by cutting frequencies to control feedback, we should take note here that we don't need or we should not sacrifice yung sinasabi natin kaninang frequency range ng vocal and consonants that carry power and information. Ito yung sinasabi ko. So, when you're equalizing a system, you should be careful in cutting or boosting frequencies. Okay? So this is all about controlling acoustic feedback. The seventh and the last objective is avoid acoustical defects such as long and delayed reflections. Of course, ito na yung palagi nating sinasabi kanina na with this type of room, which has a long reflection or cue ball, which may cause delay more than 60 milliseconds, we really need to put reflectors and diffusers in that particular room. Okay? So, to summarize our 7 sound system design objectives, first, you should respect the architecture of the space. At the same time, respect also the architect of the space. Number 2, distribute direct sound evenly to the listening area. Ito yung sinasabi natin distributing sound in terms of proper placement of speakers and proper selection of speakers. Provide adequate intelligibility. We have several factors or parameters that we need to bear in mind so that intelligibility will not be affected in that particular area. Fourth one, you should deliver sufficient level or SPL, frequency response or bandwidth, and natural sound for intended use. Ito yung sinasabi natin na by getting natural sound quality for intended use, we need to check the material, we need to check the type of project that we'll be using, that we will be considering in terms of designing a loudspeaker. Next, ito yung part ng about perception of sound and localization. Here, we need to provide the proper localization or proper perception that the sound will be coming from the source by employing delay speakers and by properly calculating the time delay of the speakers. Next, control feedback. Also, we also need to carefully consider this one because we have, even though we have a proper loudspeaker design, but if we will not control or eliminate feedback in our system, the system is still not usable. Number 7, last one, avoid acoustic defects such as long delay reflections by really employing sound absorbers, diffusers, or in general, with these 7 objectives, we really need to, one of the most important things here is really to consult a acoustic engineer to treat the room. Because with these objectives here, we're just making some guidelines considering that the room majority is with reverberation. But in order to have a more controllable sound propagation ng room, mas maganda talagang matreat ang room. Okay? So that's the one of the important factors to consider also. So we need to discuss the project owner, we need to discuss the interior designer and architects. If we've seen that the room is really need to be treated, then kailangan natin ipatreat. There's no equipment or system or technology that can cure a problematic and reverberant space or room. Only treatments. Kahit gaano kamahal or kaganda or kahit directional yung system, but yung room talaga is problematic, wala talaga tayong magagawa. So sometimes the acoustic treatment of the room would cost more than the sound system. But this is important because kung hindi talaga natin ma-stabilize yung behavior ng sound in the room, wala talaga tayong ma-achieve na tamang clarity ng tunog and intelligibility ng message. Okay? So, these are the sound system design objectives. Next stop is loudspeaker modeling, which is a very nice topic. But before we will discuss this one, I think we deserve a 5-minute break, Engineer Bai.
Okay, sir, let's have a 5-minute break because our participants are also asking for a quick break din po. Sige po, sir. No problem for that
Have
one.
a 5-minute break and then let's be back
Yes.
in a while.
Yes.
Engineer Bai, i-pause ko lang tong ano ko, naka-share.
Okay pa, sir. No problem from our end. So to our participants, now it's the time that you can go to your restroom or grab a quick coffee or any drinks or snacks so that you will be refreshed when we will resume again our webinar. So just a quick check. So if our participants are still here with us, both in YouTube and in our Zoom platform, can you please type in our chat box #Team Ross, #Team Ross. All right. Yes, Sir Sajid. Fries and iced tea time. Sana, sir, mapadalhan mo rin ako dito, sir. All right. Yes, so we really have engaging participants. We are immensely grateful and blessed that we have this kind of participation in our webinar. So maraming salamat po. And we hope that you are enjoying our first technical webinar session of our Trio-CPD-nario. Okay. All right. So we are 215 strong here in our Zoom platform. Yes, very interesting. Yes, I agree with Sir Rio. The topic is really interesting and is also aligned to us as an electronic practitioners, especially when we are designing or selecting equipments especially in audio systems. Yes, Sir Jeffrey, it's really very comprehensive. So I think are we still have any participants in our YouTube channel? So if you are still there, so just also drop your full name so that we can check your attendance later on. All right. So are we also expecting the same participants for tomorrow in our day 2 of our Trio-CPD-nario to our participants? Did you also register for our day 2? All right, yes. So thank you so much to everyone who have been very supportive to IECEP, especially to Team Rizal, Oman, and Soc Sergeant po. Sana naman po ay napapaligaya at napapasaya po namin kayo, and we are trying to give you the best webinars that we can offer, especially during this time of pandemic. So thank you so much po talaga. Okay. Yes, I believe informative and comprehensive. Thank you so much po. And of course, I would like to take this opportunity to thank our constants here in who have been very supportive to IECEP, Rizal, Oman, and Soc Sergeant. So shout out po at maraming salamat to our National Director Lyle Anthony Villas, and of course, Engineer Sherwin Rico Flanca for supporting Team Ross all the way. So our Zoom platform is medyo very generous talaga si Director Lyle sa atin. And of course, we have Engineer Sherwin Rica Flanca who is assisting us in our YouTube live po. So maraming salamat po, Director Lyle Anthony Villas and Engineer Sherwin Rica Flanca.
Bye.
Yes po.
Bye. I just want to, since it's we're still on break now, I'd like to give a quick shout out to the Batangas Governor, Gov Myra Manalo. She's with us right now. Hello po, Gov. Welcome to the Trio-CPD-nario. I'd also like to extend my congratulations to the newly conferred ASEAN engineer, Engineer Alicar Prado. Nandito si Sir. Ayan. Governor Jimmy Santos will also be conferred as a member of the AER in the coming week. So kay Sir Jimmy, Team Ross pa rin, congratulations. Also, I'd like to give a quick, a resounding hello to Kuya Jeff, the former governor of Caraga, Engineer Jeffrey De Leosa. Ayan. Teka, tingnan natin ulit. Since we're still waiting for our speaker, have we missed anybody? Ma'am Michelle will be joining us later on, by the way. May pa-shout out na tayo.
Yes, may pa-shout out kami. So who wants to pa-shout out dyan, just drop your message in our Zoom chat box and in YouTube live. Okay. Shout out po daw sa ating speaker from Mark Yulo of Soundtech Philippines. So hello and good evening po, sir.
Mambay, have we informed our attendees? Trio-CPD-nario, syempre, first tranche is today and tomorrow. The next one, when nga yun, Miss Bai?
July 23 and July 24.
Okay.
So we have 4 topics for our Trio-CPD-nario.
All right. And we also have another tranche. We have 3 tranches for Trio-CPD-nario. Before po kasi, sunod-sunod siya. But syempre, since we are aiming for free webinars with CPD points, inaantay natin yung approval for the other tranche. So, kaya po sa July, we only have 2 tranches. So, 4 webinars, dalawang series, kumbaga pa, or dalawang round. Yung third round po, watch out for it. It's going to be on August. Sa August po yun. Ayan.
Okay. So, yun. 4 muna this July. Kasi syempre naman gusto natin ng approved CPD units for our IECEP members.
Yes, exactly. Okay, I'm gonna turn off my video now. Thank you so much for giving me the floor. Bye. Take it away.
Okay po. So let me check if our speaker is there. Okay, hello po, sir. Welcome back.
Yes, welcome back.
Our fresh na po.
Okay. Are you seeing my screen now?
Yes, sir. We can see it in loudspeaker modeling is shown in our screen.
So we will continue with the loudspeaker modeling. Okay. Just to share with you, by definition, this is the process of drawing dimensions of a venue into a dedicated prediction software. Okay. What you see here is a sample of a venue with simulation. Okay. So in simulation, we'll be placing speakers and we will be predicting the model of speaker or speakers and examining how the coverage area, SPL, will function across different frequencies. So in simulation, we'll be concentrating more on the coverage area or the coverage. Second is the SPL of the entire area that we need to cover. And third is the frequency response or the frequency range or certain frequencies that we need to examine, meaning in related to frequencies, we need to examine if when we simulate the voice frequency, we need to check in our simulation kung ano talaga yung response niya in a venue. Hanggang saan talaga siya magko-cover properly dun sa audience area. Okay? And then, so as a designer, we need this simulation so that we can place the speaker in the most acoustically optimal locations. Hindi lang basta-basta tinitingnan natin na pwede tayong maglagay ng speakers dyan, but through the use of prediction or simulation software, makikita talaga natin kung nasaan talaga yung kung nasaan talaga yung coverage ng speakers in general. And of course, it will save us labor and other effort instead of trial and error. Before kasi, when we are still doing the manual calculation or prediction of the coverage of the speakers by the use of, ang pinaka-common dati sa experience namin is by using protractor. You have a plan, ipa-plot mo yung location ng speakers, tapos iti-trace mo using yung angle of dispersion horizontally using a protractor. From there, makikita mo talaga yung coverage ng speaker by knowing the horizontal dispersion angle. That's the horizontal dispersion angle. But let's bear in mind, again, that sound is three-dimensional. Yung dating way of predicting the location of the coverage of the speakers is only the horizontal domain. What about the vertical domain? Okay? Which is so sinasabi natin, pag three-dimensional, we have the X and Y and Z axis. Okay? So, we're fortunate that some manufacturers produce their own proprietary software, prediction software. But there are some limitations. Some softwares are not in 3D model, only in 2D. So ito yung sinasabi natin na may limitation pa rin. Kung 2D lang siya, hindi mo talaga ma-properly simulate yung or mapipredict yung tunog kasi hindi mo na properly evaluate in the three-dimensional domain. Okay. And then another limitation is this one. Dahil nga proprietary siya ng manufacturer of the speaker and the software, wala talaga yung ibang model but their own model manufactured. Hindi siya maging hybrid, kumbaga. But as a designer, in real applications talaga, hindi ka lang magpo-focus sa isang brand or several models. As what we've discussed in our previous slides, we will design a speaker system in terms of venue application. Yun ang pinaka-parameter talaga natin in terms of loudspeaker design. So, hindi tayo mag-stick lang sa isang brand or several models of speakers. Okay? And another limitation, may mga ibang software na dinevelop lang nila yung software because just to calculate line arrays. Paano naman yung mga coaxial speakers? Paano naman yung mga ceiling speakers or column speakers? Which is, we also need to consider in our design. So ito yung mga limitations. But of course, we are fortunate that we have free software na magagamit natin in predicting, in loudspeaker modeling. Okay? So, maraming mga modeling softwares sa market. Okay? But we would just like to share with you kung ano yung basic order of events in setting up speaker prediction. Ito yung pinaka-importante. Dahil each software has their own functions, yung mga tabs nila sa software nila, and each manufacturer of the software and the speaker have their own algorithms in the software. Okay? So, ano yung pinaka-basic of the events? Parang pinaka-guide lang kung paano tayo mag-set up ng speaker prediction sa any type of software. Any type of software. Ito lang yung pinaka-basic order. Okay? First one, begin by using coverage angle drawings overlaid on existing drawings of your venue. So, ito pa rin yung sinasabi ko na magsimula pa rin tayo sa basic. Ito yung dati. So, may floor plan ka with top view, walang cross-section. Kasi mayroon, in reality talaga, meron talagang mga buildings na wala talagang cross-section or mali-mali na yung cross-section. So, hindi siya reliable. So, but again, the first step is kailangan mong mag-sketch, kumbaga, para may initial idea ka na, ito yung more or less ito yung type ng speaker na pwede kong ilagay dito before going into the actual software. Okay? And with the basic knowledge about horizontal and vertical dispersion of the speakers, the sensitivity of the speakers, and other important technical specifications of the speakers, pag alam natin yon, at least may idea na tayo, ito yung kailangan natin. And then another factor is the size of driver, meaning 8-inch, 6-inch, 12-inch, 15-inch. Or coaxial, or line source, or column speaker. So, knowing those information that we have shared a while ago, dito pa lang sa first step, may idea na tayo before going into the actual manipulation of the software. Next, examine what and which components in your systems need modeling. Voice, music, or sound effects. Meaning, dapat intindihin mo muna ano ba talaga, aside from placing the speakers in the right position, dapat i-evaluate mo talaga ano bang kailangan nating i-model. Yung voice. For example, so, if your project is for speech application, kailangan mong i-model yung voice or yung voice frequency. Alam natin yung voice frequency na nasa mid-high part. So, alam natin kung ano yung isi-set dun sa simulation software to simulate the voice frequency and the coverage and response in that particular area. Music. Alam natin na music, medyo malapad yung bandwidth. Okay? So, starting from the low frequency for the bass and the high frequencies for the treble. So yan yung range ng music. So alam natin kung ano yung kailangan natin i-simulate. Simulate natin yung bass, simulate natin yung highs to get the proper tonality of the speaker in the venue. Sound effects. Ito hindi masyado tong kino-consider, but ito yung sa may mga applications talaga na kailangan ng sound effects, meaning kung yung sound effects mo magagaling sa left, extreme left or right, or for a surround system kailangan mo na sa likod, kailangan mo maintindihan kung kailangan mo ba siyang i-simulate dun sa design mo ng speaker and other factors na kailangan i-simulate. For example, another thing is that yung monitor speaker na nasa stage, kailangan ba natin i-simulate yung tunog nun? Depende. The answer could be yes or no. Yes, if yung monitor speaker naka-fix lang talaga, pwede mong i-simulate just to get the coverage of the speaker in terms of location of the performer on stage. In terms of height of the singer or speaker, pwede mo siyang i-simulate. But kung ang monitor mo naman is kung saan-saan nilalagay, it's useless to simulate na hindi naman yun talaga yung fixed position niya. So we need to understand these things bago tayo mag-simulate, or what and which components of the system. System meaning the speaker system. Next, ito na yung actual manipulation ng software. You need to build the venue or at least outline dimensions of the audience area. Take note, audience area. That's our main focus of the concentration of the direct or sound energy. Not the walls, not the floors, not the alleys, but the audience area. Okay? So at least, maisama natin sa pag-build ng venue. And then, include all important details. Meaning, kung may mga walls yan, or may mga barriers yan, na kailangan mong i-consider sa simulation dahil makaka-affect sa tunog, isama natin. However, in building a venue, ito yung medyo matrabaho in terms of designer. Yung iba talaga, kumukuha talaga ng mga expert dito, ng mga draftsman or na gumagawa ng venue, not the sound system designer. Bakit? Dahil yung may mga software kasi na from the PDF file of the PDF format of the floor plan, pwede mo siyang i-export into the software para ma-create ang venue. However, meron dong mga planes na pag nag-generate ka, hindi na siya kailangan sa software in terms of simulation. So, ito yung mga useless na mga planes dahil hindi mo naman kailangan makita sa simulation. And kung nakalagay lang itong mga planes dito or yung mga walls or ceiling part dito sa software, pag sinimulate mo siya, baka lang makapag-add up ng extra data sa software, babagal yung simulation mo ng software. Okay? So, yung iba talaga in building a venue in the software, may mga expert talagang gumagawa nito na gumagawa lang ng venue. Yun yung trabaho nila. Yung designer, nagdi-design lang ng speaker sa particular venue na nagawa na. Okay? So, yung mga hindi kailangan sa pag-build ng venue, sa drawing, wag na natin isama. Yun yung message dito. Dahil may tendency lang na kung hindi mabilis yung yung laptop o desktop mo, hindi mo masa-simulate ng maayos, tatagal yung trabaho. Okay? Next. So pag nakapag-build ka na ng venue, pwede kang mag-assign ng mga acoustic textures to the venue. Yung parang real texture talaga ang venue surfaces. Unfortunately, most of the softwares, hindi talaga nila kino-consider yung walls and ceilings, yung type of material with corresponding absorption coefficient. Dahil ang standpoint kasi ng designer ng mga software is to simulate the sound in the area of coverage, which is the entire audience area. Hindi talaga niya main objective na mag-simulate sa mga walls or ceilings. Okay? However, ang isang argument naman dito, ang sasabihin naman ng mga arkitekto, kailangan kong makita kung saan tatama yung tunog mo sa walls and ceiling. Okay? So, ang may provide lang ng most of the softwares is yung parang simulation sa ceiling without considering yung absorption coefficient ng mga materials sa walls and ceiling. Dahil hindi talaga kontrolado ng mga manufacturer ng software yung mga ganyang factors. Okay, but there's one software in the market na meron talagang capability na ganun. Ito talaga yung ito talaga yung dinevelop lang software to consider the type of material, and you can also input parang absorption coefficient ng material para ma-determine mo talaga yung frequency response ng speaker in that particular area. But most of the softwares developed by manufacturer, walang consideration na ganun. Okay? Next. So, next part is establish audience area. So, ito yung pinaka-importante. Again, ito yung sinasabi natin na kailangang ma-establish natin yung audience area. There will be two factors here. Again, yung listening height. Yung audience ba sa particular area is sitting or standing? Because they will have different heights. As a common standard dun sa pagsiset ng listening height, for sitting, it's between 1.1 or 1.2 meters. Depende sa lahi ng tao. Meaning, pag mga Asyano, ang sinasabi nila nasa mga 1.1 or 1.2. But yung mga ibang lahi na medyo matatangkad, iba naman yung guidance sila doon. Say for example, baka nasa sila, 1.3, 1.4 or within that range. So kailangan din natin maintindihan yan. Or else, hindi mo makuha talaga yung tamang simulation dahil mali yung reference mo. Standing. Ang common setting nasa mga 1.7, 1.8. Kami, we usually use 1.8. Of course, again, depende sa lahi ng mga tao. Pero dito sa atin, pwede tayong mag-set ng, depende, basta kami 1.8. Okay? So, kailangan i-model natin audience area dahil nga yun ang purpose talaga natin. Okay? Next. So, this is now on the actual placement of operation of speakers. So, place your speakers into the venue with proper labeling. So, in terms of manipulation of software, kailangan na proper labeling para maayos yung manipulation natin ng software. And then, we need to configure your speakers by setting positions in terms of X, Y, and Z axis, three-dimensional, and aim in terms of the angle of dispersion, and then meron pang sinasabing panning left and right, up or down, tilting. Okay? And then power setting. Some softwares have their own DSP setting in their own software that would affect in the calculation, or para siyang kumbaga itotono mo na talaga. May mga softwares na ganon. And then of course the time delay. When you're dealing with several speakers, kailangan mo talagang main and delay speakers, kailangan mo talaga ng time delay setting, etc. So this is more on configuring or placing of speakers in the venue and configuration. Next, run statistical models. So kailangan so ito yung sinasabi ko na isa-simulate na natin. And so during the simulation, you will be seeing sound coverage. So pag nag-simulate tayo and then hindi pa tayo satisfied dun sa expected natin na result in terms of sound pressure level in all areas within the audience area, hindi pa tayo satisfied sa frequency response, we should refine all settings until we achieve the desired result. If okay na tayo sa result, based on the technical requirement of the project, of the venue, of the material and other considerations that we have discussed earlier, that's the time na yun na yung reference natin na simulation. Okay. But let's bear in mind lang na itong gagamitin nating references or modeling or prediction of the response or performance of the speaker, this is just a technical guide. Considering na pagdating talaga natin sa venue, and considering na hindi natin na-input yung reverberation time and type of material sa wall sa ceiling, expected talaga na may konting adjustment talaga tayong gagawin. But at least, with the aid of simulation software, we can more or less say na nasa mga 90-95% na tayo dun sa objective natin of designing a system in that particular venue. The other percentage, yung sa overall implementation and design, is on the actual adjustment pag nasa venue na tayo. But in terms of location of speakers, okay na tayo. In terms of SPL, more or less nandun na tayo. In terms of frequency response, magbabari din yan dahil nga hindi natin na-consider yung acoustic material ng mga walls and ceiling. So, yun yung kailangan nating i-adjust sa actual na venue during the tuning and calibration part and equalization part ng venue, ng speaker system in the venue. So ito pa yung kailangan nating i-achieve in order to get the full good design of the speaker system in a venue. When this is done, okay, when you have produced good coverage, another factor to consider is the target budget. Okay? Dito minsan nagkakaroon ng parang thorough discussion or I'll not say compromise, or dito minsan nagkakaroon ng palitan ng deliberation or discussion between designer and the project owner. Dahil sa point of view ng designer, in terms of technical requirement ng venue and considering all the factors, ito talaga yung tamang location ng speaker, ito talaga yung tamang speaker. However, pagdating naman dun sa part ng owner that will be paying for the project, wala ka sa target budget. So ang ginagawa talaga natin dito, we need to make another design option, or else, or kailangan talaga nating makipag-usap ng maayos dun sa owner na ito talaga yung kailangan mo. Kung in case sa actual experience natin, kailangan talaga mag-downgrade ng system, meaning kailangan magpalit ng speaker system with lower sensitivity, meaning mas mura, or may speaker na kailangan talagang magpalit ng mas maliit na size ng driver from 12 or 15, gawin mong 12. We also need to, as a designer, we also need to explain to the end user or the owner na ito yon. Kung ito yung implement natin, ito yung response ng system, ito yung i-expect mo na performance ng system. So, doon papasok na yung parang compromise or negotiation na ano bang kailangan mo talaga, or ano bang mas matimbang, yung actual talaga requirement system or kino-consider mo talaga yung budget. Okay? So ito yung mga factors na for designer and for installer or supplier like us, ito talagang na-encounter namin sa venue. Meron talagang mga adjustments. Meron ding situation na baka pwede natin gawing by phase. Meaning, ito muna yung main speaker, tapos yung field speaker mo natin or other component of the system, ito munang ganitong type ng speaker na mas mababa, or soon in the future, pwede tayo magpalit. So ito yung mga considerations. So I'm just sharing yung actual na nangyayari sa field or sa real world in terms of the perspective of designer saka sa actual talaga nakipag-negotiate sa mga project. After this one, we need to collect all technical data, mounting positions, angles, locations, and other settings. With the aid of simulation software or modeling software, ang magandang factor dito is pwede nating i-present sa arkitekto o interior designer yung mounting positions or yung mechanical data o yung bigat ng speaker, laki ng speaker, which is balik naman tayo dun sa unang objective natin, we should respect the architect of the room. So ito yung mga kailangang inego pa or i-discuss sa interior designer, sa architector, and sometimes to the structural engineer of the building. Pag nagsabit ka ng line source or line array dito sa particular above the stage, kakayanin ba ng structure? So ito yung mga factors na kailangan i-consider. Okay. So, technical rigging data, maibibigay natin sa kanila. Yung angles, maibigay natin sa kanila. Yung locations and other settings, that will be used for the installation. Okay? So, there are several simulation softwares. So, ito yung sinasabi natin na is. Ito talaga yung nila. Nag-develop sila ng software, especially this one, is ito yung standard na version talaga. Ito talaga yung kino-consider na nila yung walls and ceilings, yung property na material. This is talaga, kailangan mong ito yung paid version. Ito talaga yung real and complete simulation software na is. Hindi sila manufacturer ng speaker. Ito talaga yung nila. Kumbaga forte ng company nila, developing software. Simulation software for room modeling and speaker modeling. 3 softwares is focus. Ito yung generic software for aiming. Ito yung mga free. Itong dalawa. Ease focus is for simulation of coaxial speakers, line array speakers, column speakers, while ease address is a free software for distributed systems, ceiling speakers, for PA BGM system, ito yung ease address. Ito yung mga libre. Ease evac, ito yung paid software which is ginagamit ng mga designer of evacuation system. Kaya binabayaran talaga to. With this software, dito makuha yung hindi lang SPL, but the SPI reading, dahil nga sa NFPA 72 standard, kailangan mo talagang ma-attain yung 0.5 na STI reading sa mga evacuation system. So these are 5E softwares na commonly ginagamit sa industriya ng audio. There are lots of softwares sa website ng AFMG. Pwede nang i-check. Mayroon pa sila mga tuning software. But ito yung common na ginagamit. For free software, ito yung dalawa. For serious simulation, ito yung ease. For other softwares, by manufacturer, marami tayong mga softwares in the market. We have the DNB Array Calc. Ito yung common na ginagamit ng mga software sa Philippines. May Myers Sound na Map 3D. We have L Acoustic Sound Vision 3D modeling software. We have Bose modeler software. So ito yung mga some popular brands or common brands in the market na ginagamit natin sa industry. Another softwares, we have Martin Audio Display 3 software. For JBL, we have DDA, Digital Direct Analysis software. For Electro Voice, we have Sonic Q, sound system software. For Nexo, we have NS1. Okay? These are the softwares. So, meron silang iba-ibang parang method of manipulating the software. Meron sila ibang technology in getting the SPL, the coverage and frequency response. But overall, kung ano yung na-discuss nating pag-design ng system using software, applicable dito. May mga dinagdag lang sila. For example, may mga softwares na ngayon na nag-auto-calculate na ng mga line arrays. Majority of the softwares. So, hindi mo na kailangang i-aim pa individually yung mga component. Automatic na silang nagka-calculate. Saka nag-i-aim. So, yun yung mga bagong technology ng mga softwares. Okay? The next part is I would like to do a modeling, loudspeaker modeling actual demo. If we still have time. Engineer Bai, we still have time?
Yes, sir. You can do a demonstration pa, sir. I think our participants are interested on this pa. Sige pa, sir. Proceed pa.
Okay, thank you. Engineer Bai, can you see my
Yes.
full screen now?
Yes, sir. Loudspeaker modeling actual demo. That's what it
Full
means.
screen. Okay. Um, okay. Let's start first with the floor plan. Let's say we have this venue here with 540 seats. This is a Christian church with this particular layout. So we have created the venue out of this PDF file, pero mas mabilis sana kung AutoCAD file ang nakuha natin, then we will export into the software that I'm using, and then mas madali sana and mas accurate yung mga figures. But coming from this PDF file, we have generated a 3D model. This one here. Engineer Bai, sorry. May nakita kayong ano ngayon? Nakita yung screen ko?
Yes, we can see your screen po.
Okay, sorry. I'm monitoring kasi sa YouTube. Medyo ano lang. Okay.
Merong konting delay lang po sa
Yes.
YouTube.
Okay. So I also need monitors. Okay. First one. So this is the venue. From the file, this is the ceiling, the full 3D venue. Let's remove the ceiling. So makita natin yung venue ngayon. Okay? So this is created from the PDF file. And then the first thing to do is seeing this venue, alam natin na, for example, this is the reference point of the software. This is the Y, X, and Z, the blue line. It is three-dimensional. So ito yung reference point sa gitna. With this venue, may mga settings na kaming ginawa dito. Upon seeing this venue, so dito tayo, ito yung initial location talaga kung saan tayo maglalagay ng speaker. So carefully evaluating the venue, nasa mga almost 20 meters siya. So meaning, hindi talaga pwedeng coaxial speaker. Okay? Hindi talaga pwedeng coaxial lang ang gagamitin dito. And then, second consideration, meron tayong enough na mounting height ng speaker, which is one consideration na makapag-decide tayo na with this large venue, with this depth of the venue, kailangan talaga natin, and with this type of application, dahil this is a Christian church, ang application talaga nila is speech for preaching and full band. And then knowing the requirement ng full band nila, ang sabi sa amin ng end user is mga youth yung band members, meaning ano talaga, they need high SPL system. So with that consideration, based dun sa diniscuss natin a while ago, considering all the factors, so kailangan talaga ng type ng speaker which is line array or line source. Okay? Ngayon, what size of the driver of a speaker? For this venue, nasa mga below 20 meters lang, mga 17 meters, 18 meters lang to. From the front here, up to the control booth, because we also need to cover the control booth dahil ito yung dito nakikinig yung sound technician. They also need to hear the same sound kung anong narinig ng audience, of course, to have a proper mixing of the system of this venue. So hanggang dito talaga tayo. Okay. So 17 meters lang, maliit lang, hindi masyadong malaki yung mahaba yung depth. Ang nasa consideration natin is hindi nang ganun kalaki speaker. Hindi kailangang 15-inch or 12-inch dahil hindi naman ganun kalaki yung venue. And considering also the budget, so with this particular venue, ang dinesign namin is a line source with a speaker model that has a driver of 10-inch. Okay? 10-inch. Ang factor na lang dito, ilang speakers ng 10-inch sa line array. So that's what we need to know sa actual na operation na simulation. Okay. I have here okay. So, first, we need to activate audience area. We need to put audience area. Okay. Audience area seating with height of 1.2. So, kung makikita nyo kanina sa floor plan, itong mga blocks na to, ito yung audience area, ito yung seating areas here. And then this one here, ito yung area ng sound tech booth. So, our interest here is to cover these audience areas or seating areas represented by itong blocks elevated at 1.2 listening height seating. Okay? If you have the audience, okay, meron tayong speaker system. First, let's set a speaker. So, initially, tinitingnan natin yung tatlong boxes ba, ng speaker, mako-cover ba yung buong area? Visually, yes. Okay? So that you can properly view the venue, i-disable ko lang itong mga walls. Okay? Left wall and another wall. Okay. Okay. Hindi natin tinanggal dito yung left wall para makita natin, pwede nating makita yung tama ng speaker natin na pwede nating ipakita dun sa owner and architect na this part of the walls should be treated. Dahil ito talaga yung tatamaan. At least makita nila. Okay? So, initially, may speaker na tayo. Nakita natin na nako-cover natin hanggang sa tech booth. What about this portion here? Which is hindi tinatamaan ng speaker. So ito yung mga bilog, ito yung sinasabi naming impact points of speakers. Doon tumatama yung mga speakers. And ito yung mga kulay, ito yung SPL reading correlating to this one here. Okay? So in short, pag-click natin dito, makikita natin kaagad 102 dB tayo, SPL, at 6.48 meters. So with the aid of software, makita natin kaagad, makita natin na ito yung expected na tunog in this particular area with the bandwidth bandwidth of 1K to 10K. Unweighted. Okay? Unweighted. Full frequency range. Okay? Ngayon, nakikita na natin. So, if we will make, ito yung left cluster natin. For example, i-try natin na ganyan. If we'll make another same cluster at the right, anong mangyari sa kanya? Nakikita natin kaagad, dito pa lang, makikita natin na hindi to properly covered. Okay? Hindi to properly covered. Okay. Ngayon, so, hindi muna tayo magdadagdag ng right cluster. We will carefully or properly aim or position the left cluster. Okay. So, paano natin makikita yan? we need to check the SPL frequency response and coverage. Okay? So, this is the coverage illustration here. Okay? It says 83.3%, which is not enough. We should aim at 100% coverage, of course. This part here is the SPL or the target curve. This line here, this is the SPL deviation, plus 3 dB, minus 3 dB. Within this line, within these two lines here, ito talaga yung target natin. With the deviation of plus or minus 3 dB, acceptable pa rin siya. But seeing here, makikita nyo, masyadong malakas to. Masyadong malakas to. Ang pasok lang dito is itong mga points na ito. Giving us 84.8% target lang. Okay? With a flatness of 2.1 dB. Flatness meaning 1K to 10K relating to the frequency, the high frequency. So anong kailangan natin gawin ngayon? With this type of software, meron tayong sinasabi na, ito yung sinasabi natin kanina na meron na tayong automatic or parang automation function. Okay. Paano natin gagawin yon? May function tayo na nung napapansin nyo, nagbabago siya. Nag-auto-calculate siya. Nag-auto-aim siya. And then, let's optimize. Still 83.3% pa rin. Okay? So meaning, hindi ito yung tamang location. Dahil, visually, makikita mo talaga na hindi talaga properly covered yung buong area. Okay. Let's check dun sa horizontal. Okay. With this horizontal view, okay, kailangan natin mag-adjust ng angulo. Okay? Kailangan natin mag-adjust ng angulo. Say, okay? Nag-adjust ako ng angulo for proper coverage. Nag-improve. You can see, naging 96%. Okay? Naging 96%. 82%. I-automate natin, automate function, and optimize. Nag-improve, 84.6% ang coverage, 91% ang target. Hindi pa rin. So, anong problema? This area here, sa gitna, hindi properly covered. So, kailangan nating i-move, papasok. Okay. Let's try this one. Visually, nakikita natin na itong area na to, unti-unting nako-cover. Plus yung other cluster, let's see, through simulation, kung ano yung response ng system. Napapansin nyo kaagad, 100% coverage. Okay. In terms of coverage, we're okay. What about SPL target? Pasok ba siya dito sa plus or minus 3 dB curve? Ito yung pinaka-importante. Meaning, from front to row, kung within 3 dB curve tayo or deviation, plus or minus 3 dB, meaning, kung ang average natin is 95 dB, 98 dB plus 3, 92 dB minus 3, yan yung allowed deviation nung SPL target curve natin. So let's again automate, mas madali na ngayon, and then optimize. Kung napapansin nyo, 99.6%, 100%, and then yung, kung titingnan natin yung frequency curve, yung flatness niya is 2 dB. Pakita natin. So ito yung average. Itong mga lines na to, red and blue, ito yung impact points, ito yung mga bilog ng speakers, kung ano yung response niya dun sa audience area. Pakita natin yung average ng frequency response, which is more or less a few bumps here, high frequency, a bump here. Okay? Paano natin more or less ipa-flatten yan, because our objective here is to have a flat, more or less flat response of the system. Let's check with the electronic setting. Ito yung sinasabi natin na meron tayong okay. Okay? Meron tayong electronic setting. I-automate din natin yung mga filters through the software. Okay? C, through automation. So, software itself pa lang, mas madali na yung buhay natin ngayon as a designer. Dahil we can see the figures. So, from the manufacturer ng software point of view, dinevelop nila yung algorithm, and then itong nasa software na to, ito yung actual na acoustical property ng speaker na nilagay nila dito sa algorithm ng software, calculating it, and then using deploying functions of automation. So ito na yung response talaga ng system. If you can see here, 100% coverage, we're okay with the coverage. SPL target, nandito tayo sa SPL target curve, which is plus or minus 3 dB. Target is 100%. Integrity is 97.3, which is acceptable. Okay? And then flatness, kanina 2 dB, ngayon 1.7. Ang curve is nag-flatten na konti. Okay? So itong curve na to, ito yung initial curve. But during the actual tuning, kailangan pa rin ang final na magdi-decide pa rin is yung tenga na magtutono. O kung ano talaga yung gustong tonality ng designer, considering doon naman sa gusto ng end user. Okay? Because the designer may have different tonality preference as the owner or the end user. Because sound is subjective. Kung maganda sa iyo yung tunog, pangit sa akin, ako magbabayad, ako gagamit, pangit talaga yan. So sa designer point of view, kailangan mo talaga talagang i-consider yung factor na ganyan. Okay. So with this system, I am now ready to have my right cluster. As easy as that. Okay? Left cluster, right cluster, FIR. Okay. Okay. So I have a left and right system here. Ngayon, so I will be simulating the main system, which is left and right main cluster. Okay. Okay. If you can see here, wala akong problema dito sa area na to up to here. And I have a more or less an average of 95, 96 dB within the entire area. Okay? Okay? So, yan yung objective naman natin. Dahil nga music ang application niya. So, with the software, ito yung kung 95 dB ang average, sa algorithm ng design ng software, meron pa tayong headroom na 10 dB. So, that's more than enough. 10 dB is quadruple ng power. So, more than enough. Okay? So, in terms of coverage, okay na tayo dito, but we can see here kulay green, which is nasa mga 88 dB, which is very low compared to the 96, 95 dB average. So what I'm going to do is to put a sinasabi nating field speaker here. Okay? Yun yung next na objective natin. Next objective. For field speaker, papakita natin mamaya yung actual talaga na design. For field speaker, yan. Okay? So, meron tayong nilagay na field speaker just for that particular area. And then, we will check if time alignment is needed for this particular two types of speaker. We can see that because we can see the alignment scale or the delay scale. Okay. For this particular, ito yung response nung dalawang system, delay and main and fill. So wala tayong source unaligned. We have common sources mode. Ito yung bilog na to. Common dahil dito nagkakaroon ng dito yung dispersion ng main and delay. This is the common. But for single mode, kulay blue, single mode for here and here talaga. So wala tayong unaligned sources. Pero kung meron tayong unaligned sources, kailangan nating lagyan ng time delay and we can get the common mode or the single mode. Okay, so yan yung field speakers natin. Next is subwoofer. Ang next question natin ngayon, saan natin ilalagay yung subwoofer? Okay? Ang sabi ng end user, hindi pwede sa gitna o sa ilalim, sa ground stock, dahil may sumasayaw dito sa part na to. Okay? May dumadaan dito or may sumasayaw, obstructive, hindi pwede. At the same time, placing subwoofers here, pag tumunog yung subwoofer ng malakas, yung mga nakaupo talaga dito, which is mostly may mga edad na or lalo na yung mga VIP, hindi talaga nila kaya yung subwoofer, yung tunog ng subwoofer na malakas. Ang tendency, pahinaan nila, yung subwoofer lang, magkakaroon naman ng issue in terms of proper coupling ng subwoofer and ng flown mid-high speakers. So that's a problem. Pag hininaan mo naman lahat, subwoofer together with the mid-high speakers, baka naman hindi tama yung coverage sa likod. Okay. So, ang solution dyan is to fly subwoofers dito sa speaker. It's either sa side, sa top, or sa likod ng cluster. Okay? So, yun yung sa part ng subwoofer. So, ang consideration natin dito, hindi pwedeng ibaba. Dapat na sa taas talaga. Ngayon, we have to consider also that kung ilalagay natin yung subwoofer dito, the distance between subwoofer and mid-high speakers is far. So, we will be having parang alignment in terms of proper coupling of low frequency and mid-high frequency. So, yun naman yung kailangan nating i-align pag nandito. Whereas, pag yung subwoofer malapit sa speaker, meaning meron kasing certain distance na kailangan talaga siyang malapit yung subwoofer and mid-high to have proper coupling of bass and mid-high frequencies, mas madali dito, ideally dito. Okay? So, therefore, we have decided to put subwoofers on top of the cluster, left and right clusters. Okay? So, yun yung final design natin. And then, so, we have here a final design, which is this one. Okay. Our final design here, okay. In our final design here, kung makikita natin, we have 100% coverage. Okay? We have 100% SPL target. Pasok tayo sa plus and minus 3 SPL curve. And we have flatness of 1.5, which is good enough for this particular system in this particular venue. And if we simulate the result in terms of, so to check the SPL distribution, this is it. Okay, we have now a more or less even sound coverage of the entire venue, which is 100%, with the target SPL target of 100% and flatness of 1.5 dB. Okay, so this is now the final speaker system. But what about dito sa speaker sa harapan? Dito sa harapan. Okay? We may cover the entire venue, but what about dun sa objective natin to give perception of direction? Meaning, yung pag nakaupo tayo dito sa harapan, ang orientation ng speaker natin is nasa taas, above our head. Meaning, pag may performer or preacher na nagsasalita dito, titingnan natin yan, tapos yung tunog manggagaling dito. That would cause disorientation. Ito yung sinasabi natin na objective. Hindi yan pasok doon sa objective natin. Ang objective natin is to have a perception of sound coming from the source, which is coming from the stage. That's why we need to put speaker system we call front field. Okay. Front field. Front field speakers covering only few seats in front. Front field will give you the perception, front field for the audience seated in the front will give you the perception that the sound is coming from the actual performer or preacher on stage. So, hindi to masyadong malakas, tamang-tama lang to cover this area na hindi niya masyadong hindi niya naririnig tong speaker, yung tunog ng speaker from this part here. Okay? So yun yung purpose ng front field. Unfortunately, some of the venues wala talagang front field because they say na naririnig naman nila yung tunog ng speaker which is manggagaling dito sa flown cluster, which is not the objective of a proper sound system design. Okay? So, with this design, we can now say that our design is complete. Our design is complying all the objectives of a good scientific sound system design. And then, if you simulate this one, okay, if you simulate this one, ito yung overall coverage niya. So as a designer, getting this data and result, you need to submit technical data or visual or images to the owner of the project or the architect or structural engineer, because this portion here, you can check the mechanical data of the speaker, meaning if I need to submit the mechanical data to the architect or the structural engineer, I have the volume of the cluster, I have the total weight of the cluster, and I have the pick-up location of the motors, and all the data, the mechanical data na kailangan ng structural engineer or architect. So this is complete. I'm now printing a report and then submit to the project. And that concludes the design process of this particular project. Okay? So this is just a basic demo of simulation software that we're using Hindi na namin sasabihin yung brand because the concept here is to demonstrate or show to you the flow of the scientific design approach of the speaker system. Okay? Engineer Bai, this is the last part of my presentation. I'm now ready for, or are we now ready for the Q&A?
Yes. All right, sir. Okay, sir. I'll just be sharing my screen, sir. Is that okay?
Sure, sure.
Okay po. All right. So thank you so much, Engineer Merwin, for that informative and interesting speaking session. So I bet everyone agrees that they have truly learned a lot from your webinar po, sir, from your technical session, sir. So thank you so much. So now, sir, let us proceed to the question and answer po. A Q&A session. So I'll be flashing on the screen the first question po, sir. Hi na po, sir. Can we start po?
Yes, I can see the screen.
Okay. So the first question is from here in our Zoom platform from Sajid Makabalang. The question, sir, the question is, our government agency office is proposing an outdoor PA to support the port-wide IP-based CCTV. So for outdoor scenario like a port area, what will be the recommended brands and design consideration, and will the 3D simulation software support such scenario?
Okay. Thank you for this question. First off, this part here, this is an outdoor scenario. So this is not about, as a designer point of view, this is not about recommending a brands. But let's see the requirement first, or the application. This is outdoor. Okay. Outdoor, free field, without reverberation or obstruction. Port area, noisy. Siguro tayong medyo maingay itong area na to. Okay? And then, we need to identify gaano kalaki yung coverage and what application. PA system lang ba with music? And of course, the coverage area. From there, we can recommend a system. We're not particular here with the brand in terms of designer's point of view. We need to check kung ano talaga yung babagay sa particular area. So, again, outdoor, we need the high SPL. Port area, maingay, we need high SPL. In terms of coverage, gaano kalaki yung i-cover natin. And then, in terms of application, para saan ba siya? Speech lang ba? Music? Or may banda? So, those are missing information here that we need to consider and know first before recommending a PA system design. In terms of simulation software, pwede naman. Marami tayong free simulation software. You can check the EASE Focus 3 free software. Ang kailangan natin i-verify, if we can have parang idea na kung anong kailangan speaker natin dito, let's check lang kung yung particular model na to, meron siyang data na pwedeng i-simulate dun sa free na EASE Focus simulation software. Yes, so but simulation would help a lot para makita natin kaagad yung coverage sa buong area. I hope that answers this question.
Yes, I believe, sir, that you have answered the question. In just a summary, we just need first, what are those specifications for the design consideration? What is the application na gagawin for the audio system design? And then after
Coverage.
which, there are free simulation software naman. High SPL because it's noisy, and the coverage. That's what the two main points that you have raised po kanina, or you have provided po. So there is also free simulation software, and we can check there po. So thank you so much for that, for answering po, sir. So let's proceed to the next question, sir. So the next question, sir, is from Rizal Rio, from Sir Rio Tubon. The question, sir, is there a difference between the speakers for PA and BGM? What is the difference in terms of audio parameters, and can we use a speaker of PA for BGM?
To properly answer your question, isa-isa muna natin. So in terms of
Okay.
terminologies, PA is marami kasing um, meron kasing misconception dito, but generally PA is public address. Okay. From the word itself, public address is for speech. BGM is background music system, is for background music. Okay. So from there magkakaiba talaga yung in terms of meaning sa PA and BGM. But sa common practice talaga, PA meron talaga tong specific performance na kailangang i-satisfy. For PA system, kailangang medyo mataas yung sensitivity niya to provide high SPL dahil nga pang public address siya, purely speech. But for background music, yung music kasi is not will not require high SPL kasi background music lang siya. Typically for a hotel room or mga lobby or etc. Kung mga low ceiling lang yan, nasa mga maximum 6 to 12 watts lang yan eh. Unlike pag PA, pang public address, minsan ang sinasabi na kailangan ko ng 200 watts or 300 watts, etc. So from there, the application is totally different. But in terms of actual application sa project or design, ang common kasi na ginagamit na terminologies ngayon is PA-BGM system. Meaning, yung PA system / BGM system, ginawa na siyang integrated dahil ang PA is for paging sa indoor area. Paging at the same time background music. For example, sa hotel, ginawa na siya integrated na sinasabi na niyang hindi lang siya BGM but PA system siya in terms of paging. So ang name ngayon ng system is PA/BGM system. So yun yung kumbaga parang kailangan nating linawin dito sa part na to. But yes, we can use PA speaker for BGM system. But kung ihiwalay natin yung BGM system in terms of limitation, baka kasi ang BGM system kaya lang niya mag-produce or kasi yung mga BGM system may mga built-in transformer siya, for example, mga ceiling speakers which is limited to hanggang 6 watts, 12 watts, 30 watts and cannot produce the full frequency response unlike the PA speaker which is in low impedance mode. So magkakaiba talaga yan. But at certain extent, kung mababa lang yung level, pwede siyang gamitin. But in full application talaga, let's be careful with the, kumbaga, yung level na paggagamitin sa kanya. I hope that answers your question.
Yes, sir. It definitely answered. Thank you so much, sir. It's very comprehensive and very detailed naman po yung pagsagot niya, sir. All right. And then, sir, next question. I think this is the last question for now. So the question, sir, is from Francis Mark Bugayong. The question, sir, is could you just send pink noise or A-weighted noise to generate the coverage SPL needed in the audio simulator? Then this would be able to cover all audio frequency range.
Okay, let's define first. I already have an idea what you're going to to know about this particular topic here. So we have in the software I've shown a while ago, we have 3 types of weighting. We have the broadband setting. We have the C and we have the A. So generally for simulation, we usually use A weighting. Meaning A weighting, that's the frequency range that the ear is perceived to hear. That's A weighting. So A yun talaga yung common na ginagamit. C weighting for music from low to high. Yun talaga yung parang full frequency range more or less. Okay? But for simulation application, lalo na yung mga projects na critical yung speech, where the A weighting falls into, which is the frequency range that the human ear can perceive to hear. A weighting talaga ginagamit natin for simulation. I hope that answers your question, Mr. Bugayong.
I believe, sir, that you have answered the question. I think that concludes our Q&A, sir. So is there anything else you would like to mention or any final remarks before we will wrap up our technical session?
Yes, I would like to mention lang, of course, I'm aware that, or I know that in this session, marami sa industriya kasi namin, we're in the live and entertainment industry. So, right now, we're really devastated with this pandemic. Wala talagang business na pumapasok ngayon sa industry namin. But we're very thankful na existing pa rin. And right now, unti-unti na kami bumabalik. So, currently, actually tonight, since yesterday, may mga setup na sa, I think they're setting up now sa Araneta Coliseum for Binibining Pilipinas. So, the back to live concept now, or the vibe of back to live concept now is getting stronger. So we hopefully that we can get back into live at ma-cater na namin yung mga clientele namin sa yung mga events na hindi natuloy. So that's on our side in the entertainment industry. So let's hope and pray that magtuloy-tuloy to, and then we would like to remind everyone to be safe always. Thank you so much.
Yes, sir. We really hope that this pandemic will end and everything will be back to normal. So thank you so much, Engineer Merwin Wayne A. Gutar, for your session, for your technical session, sir. So thank you so much po talaga for gracing your presence with us. So I will be awarding this certificate of appreciation po to you. So I'll just read the text. So the certificate of appreciation is given to Engineer Merwin A. Gutar for imparting his knowledge and expertise as a resource speaker during the IECEP SOC Surgeon Rizal and Oman chapter collaboration webinar with the topic Scientific Professional Audio System Designing Principles, given this 9th day of July 2021, signed by our governors, IECEP Rizal, Engineer Dennis Molina, IECEP Oman, Engineer Jimmy Santos, and IECEP SOC Surgeon, Engineer Tanya Osorio. All right. Thank you so much, sir. So to our participants, can you please
Thank you so much.
click the clap button. So thank you so much po talaga, sir. Thank you po. So to all our participants, thank you so much for engaging with our speaker all throughout this tech session. So now, I believe that our attendance quiz and evaluation link is already available in our chat box. So you can also scan below our attendance quiz and evaluation form and link. So please ensure that you will be answering this before this webinar. All right. So now, so we already have concluded our first technical session. So now we will be hearing messages from our constants who are being supportive and with Team Ross all the way. So let us hear first a short message from our IECEP National President. Let us all welcome our very own IECEP National President, Engineer Michelle Lawas. Hello, ma'am. Good evening po.
Hello, bye. Salamat. Maraming salamat po at good evening. I think it's too late na siguro, no? It's late already, and actually I still have 2 meetings no in parallel. I have with the BFP and as well as in some of the committee, one of the committees in the national. But nevertheless, I would like to congratulate each and everyone, of course, no, everyone to have joined us today as we take time to venerate our engineers in this Trio-CPD-nario. Okay, once again, bumalik na naman siya version 2.0 with Rizal, Oman, and SOC Sargent. So I am indeed much honored na yung mga local chapters natin is talagang ginagampanan nila yung mga trabaho nila at saka yung mga pinaggagawa for mimicking no yung mga activities and programs in the national level, as well as for our chapters no na talagang they are adhering with that indispensable roles no in the development and growth of our members. So with that, yung mga webinars natin comes in different forms, and some it is also for me no it is a day or to honor and admire what our electronics engineers are doing, especially in this time of pandemic, and in this time now we are really challenged to really the frontliner in this time of the global crisis no. At saka aside from that, we are also challenged to really come up with a sustainable program and projects no na being an electronics engineer and being one of the contributing in the overall socio-economic as well as in the national development of our country. So masyado pong maraming activity ginagawa po ang national ngayon, since we are halfway of the year, mid of the year na tayo. So we are really very serious now on coming up with the plans and programs no na we need to realize that and we need to materialize that, so long as that it will really the members will benefit of all the programs no na cascaded down to the chapter. So again, therefore, this is a significant no for all our electronics engineers, for all the engineers no, and all our stakeholders. And I think this is also it will shape us and help us in responding to the challenges no na nag-confront sa atin during this time. Then I know that we are very much willing to grind to ensure lifelong learning, kasi kahit gabi na 10 o'clock, 11 o'clock, still andito tayo for this very fruitful at saka yung magandang mga topics natin, because we want to revitalize our membership and we want to revitalize our learnings in terms of topics no in line with the scope of electronics engineers. So kaninang afternoon nagko-confirm tayo conferment with the ASEAN Engineering Registry. So with that, dami tayong mga IECEP members no, there are around 105 na kino-confirm natin with different schedules. So doon natin nakikita na we are really answering, and we are on the process of competing, because this is our first time in the history of PTC, in the Philippine Technological Council. Now we are being top with their programs. So as such that our professionals also are given this opportunity to upgrade their professional learning and to upgrade their personal development for all our engineers. So with that, I hope that the negative consequences of our time, of our current situation this time, so let us be in solidarity with that, with each other, with the national officers, with the local, as long as with the committees, to really come up a meaningful endeavors in all that we do. And let us acknowledge also the actions of each and everyone who are trying to help out in our organization. So with that, thank you so much, professional electronics engineers, and our ECT for coming up tonight for this seminar, for this webinar, and of course, congratulations to our resource speaker. Ang galing niya, dami niyang na-share, dami niyang learnings ngayon, dami tayong takeaways, upon listening the entire topic of our resource speaker. So again, congratulations for this Trio webinar. Trio, we have Oman, Rizal, and Sub-Sergeant. So sa mga governors, maraming salamat, at sa lahat po ng mga IECEP, and hopefully the celebration and this webinar can spark more appreciation and can also give support to all our membership. So mabuhay po tayong lahat. Salamat.
All right, thank you so much, Ma'am Michelle, for that message po. So now at this juncture, I am requesting all our participants, guests and our resource speaker to please turn on your camera for our picture taking po. So I am requesting everyone to turn on your camera for our picture taking. So, may I request, sino po pwedeng So, let me see if, okay na po ba? Lahat na po naka-turn on ng camera. So, okay. So, let's start. Okay, 1, 2, 3, smile. Alright. Okay, so there are 8 pages. So, smile lang po tayo ha. 1, 2, 3, smile. Alright. Wait lang po ha. Okay. So thank you so much, everyone. So you can now turn off your camera and let us resume with our program. So I hope that our participants will stay put pa din po, ha? So now let me just do a quick share. All right. So I hope that we want like to thank everyone and especially to our speakers for tonight for being engaging all throughout our webinar session. So before I will going to announce our future activities, I first want to greet to my Rizal babies, to those people who I work hand in hand during a Trio-CPD-nario last year and EAGM. Hi to Vic, Bea, and Solan. So I miss working and collaborating with you guys, and I hope to see you soon after this pandemic. All right. So now, as mentioned earlier, that we are offering 4 webinars this month of July. So we are already finished with our first technical session. And tomorrow, we hope that you will be joining us with our webinar entitled Philippine Electronics Code Book 4 Best Practices on DAS Installation by Engineer Sajid Makabalang. Tomorrow, same time, 6 p.m. Philippine time. And on July 23, same time, we will have Engineer Joel Arjona to discuss grounding and bonding standards and practices. And on July 4, same time, we will have Dr. Angelo Beltran who will be discussing environment and energy revisited. So just tune in for our third tranche, which we will be announcing very soon, which we will be conducting in August. All right. So again, I will be flashing again in our screen. Our attendance quiz and evaluation form is already available in our chat box. So can you please try to accomplish that before our webinar ends. And if you have problem or accessing the links, refresh lang po and pa-check lang po ulit. Because we have double check from our end, these links are working naman po. All right. Now, before we will formally end tonight, so let us first hear words from one of the great leaders here in our organization, because she is an envisioned woman. Ladies and gentlemen, let us give a virtual of applause to our IECEP SOC Surgeon, phenomenal governor, the ever beautiful Engineer Tanya M. Osorio for her closing remarks. Engineer Tanya.
Thank you so much, bye. Ayan, so thank you to everyone. Late na, no? It's already 11. Actually, I feel na kulang yung time talaga for the topic of Sir Wayne. So anyway, I won't hold you any longer, but I would really like to express my gratitude to the Team Ross team, yung Rizal, Oman, and SOC Surgeon officers for materializing the second yung second second series ng Trio-CPD-nario, which of course we started last year. And I'm very glad and I'm very happy, and we feel fulfilled. Now we this year, this 2021, we're able to push through and continue with this series, and hopefully it would still be done in the coming years. Hopefully, no, but anyway, kung wala na sanang COVID, face-to-face na yung Trio-CPD-nario, uuwi yung taga-Oman dito. Okay, anyway, kidding aside, maraming salamat po to Governor Dennis Molina and Governor Jimmy Santos. Thank you so much for preparing everything, syempre. Kung alam niyo lang po yung behind the scenes ng lahat ng to, all of these are short notice, but still, we were able to make it, especially because Bai handled our opening salvo very, very well. Okay, excellent job to our MC, Engineer Janaisha Bai Tito. Maraming salamat, Bai, for carrying through with our first webinar for the Trio-CPD-nario series. Also, we would like to thank most especially to National Director Lyle again for the assistance with our Zoom platform that we're using right now. Thank you so much for your generosity. I hope you feel better soon. He's actually sick. Please include him in your prayers right now. Also, I would also like to thank my fellow committee member in the Publications Committee of IECEP, Engineer Sherwin Rica Flanca. He made way for our YouTube streaming to work seamlessly. Ayan po. And speaking of streaming, thank you so much as well to the hard work of the technical team, VJ, Raya, and Earl. So for those who were not able to tune in on Zoom, syempre nakikita tayo sa YouTube, and the three people I mentioned, hardworking officers from Soxargen, made all of those happen. Okay, and syempre we can never end the night without thanking our impressive speaker. Nasabi ko nga, kulang ang 4 hours for this topic. Sir, thank you so much, Engineer Merwin A. Gutor. Thank you so much, and hopefully we would be able to invite you in the coming, bigger platform, bigger avenue, and you'll be able to share more of your audio knowledge with us. Ang dami pong interested. So thank you once again, sir. And syempre, tomorrow, I'd like to invite everybody again. We are gonna have Engineer Sajid, very own from Soxargen, Engineer Sajid and Makabalang for the Philippine Electronics Code Book for Best Practices on Detection and Alarm System Installation. Ayan, we're gonna go all night long then again tomorrow. So expect it. That's definitely Trio-CPD-nario. Maraming salamat po once again for joining us. Hopefully we would still get to see you in the succeeding webinars that we are gonna have. Be safe. Have a good night. Thank you. Bye.
All right. Thank you so much for that wonderful message from our ever gorgeous Governor Engineer Osorio. So now, thank you all for attending and participating in our first tranche, our opening salvo of our Trio-CPD-nario 2.0. So this wraps up our webinar for today, and we hope that we were able to give you comprehensive insights and valuable information on the scientific professional audio system designing principle. We are grateful for your participation, and we hope that you find it valuable and informative. So we are immensely grateful to the members who support Team Ross all the way. The 3 chapters, the Trio chapters, are thriving because of your support and patronage. Kaya po, mabuhay po kayo. So we are looking forward to seeing you again tomorrow and in our future session. So please visit the Team Ross, which is IECEP Rizal, IECEP Oman, and IECEP Soxargen official Facebook page, and we will drop our announcement there. So once again, this is by your host, and God bless and keep safe, everyone. Good night.